I think all my titles have been done. Let's see if I can't get my streaming stuff worked out. Let's see here. Hopefully OTT didn't copyright his album cover. Bitrate says offline. Give everybody a minute. And then I need... Oh. Which one do I keep open? I don't know. We'll close these. Bring that over there. You right? There you go. My upload was atrocious earlier. I did a speed test and the upload was just bad. It was like 5K or something like that. It was bad. Or wait, how does it measured? I never get those measurement systems right. The Mbps ones. I don't know why I can't learn it. I just can't. I don't know. It's like a brain block. I got like a boomer brain block. Which I've had to deal with those lately. Those are so bad. When a boomer refuses to actually listen to you, it's the worst. The worst. Okay, let's see. So there's that. Best Twitch viewer, number 39. That's great. There's some great screen names on calling it a screen name probably dates me. Great names on Twitch. I do love some wacky account names. All right, so I'm gonna try to get a wire from all the way over at the power supply to the oscilloscope. And since none of my BNC cables are long enough and I don't want to order cables, I think I can use an RF cable to do this. Like one of these boys right here. One of these little guys. This is my bin of RF cables. I never use RF stuff. Where did my other social stream blade go? Or is that the current one? Is it the only one that I've got open? The multiples. No, I've only got the one. Those viewers on YouTube are listening to OTT's album called Heads. It's a good album. There's a bunch of wire scraps that are, for some reason, they're in the RF cable bin. I don't know. Maybe I should just put these in the wire scrap bin, which is down here. It's just a bank box that's filled with wire scraps. So if I can get BNC from one end of that to the other, let's see here. I have a lot of RF adapters, but I don't know if I'm fully... Oh, yeah. No, wait, that's cable. What the heck? That's like big coax. That's weird. I really needed to go to test leads. Or no, I need to go back to BNC. Okay, so BNC to SMA right there. This is BNC to RCA. That's a weird one. Other side of BNC to RCA. This is just for a voltage. It's not for RF, so it doesn't need to be... I can do like a big string of adapters and still get away with it. I don't know, though. Of all the adapters that I have, for some reason, BNC is not on the table. Maybe because they get used more often than not. It's warm in here. I'm going to have to move the fan. I'm going to have to move the fan. That fills me with trepidation. Do we have SMA to RCA? No, that would be too easy. Shit, dog. Like, I just don't have it. Really weird. You go to the big boy RF, but then that I don't have an adapter from that to BNC. Why am I lacking in my BNC? I feel like a bad engineer. BNC is so versatile. There's SMA adapters, every single kind of SMA adapter under the sun, but for some reason no BNC adapter. Wait, you're different. You're like a micro. You're a micro SMA. What the f... Okay, so apparently I can't do this. These adapters are going to be like $10 each, too. Fucking A. I shouldn't curse this early into stream, huh? I hate the censorship of the internet. Yeah, hot take. Hot take, totally hot take, steaming hot take from O'Bother here. He doesn't like censorship on the internet. Woo! What a spicy, spicy take that was. God, it's just the commoditization of the internet and turning content turns into pleasing advertisers, and advertisers are puritanical about everything, and it just gets on my nerves. I started on Twitch because you get to curse here. You can curse on Twitch. Did you know that? You're allowed to curse. I can swear like a sailor, which is generally how you get electronics to work. And by generally, I mean specifically how you get electronics to work, by cursing at them until they comply. Citizen, you must comply. Oops, I left this one out. So yeah, it kind of hamstrings the content creator. You know what? If I can find an RCA cable, I actually think I can effectively go from BNC RCA to BNC RCA. Where's the other one? Oh, this is the other one. That's not quite what I'm looking for, though. Although I could do a short run of... Let's see what I have. Do I have a singular RCA cable? That's a good question. It's probably going to be a no. Dog's barking out there. RCA. I might have an adapter for a headphone plug. That's not. None of this stuff is what I need. No. I should be so lucky. I'm having an adaptation issue today. Yeah, I don't have anything. Fuck. I mean, I could go through the big cable bin and find something, but I don't know to what end. Because I don't have... I need BNC... whatever gender this is, who cares? The BNC... Oh, that's the mail end. This little pointy bit there. Is that a package? That's probably a package. Not this. No, I'm not talking mail like this thing is a package. I mean, there's a package at the door. That's why my dog's barking. That's got nothing to do with... why is it always got to be a sex thing? All right, anyway. Maybe I can extend the banana plugs. Bananas, packages, BNC, gender. We got it all this morning. We got it all. For my viewer, right? My viewer? 7. Oh, 7's a good number. I like 7. 7's a good number of people. Why are you guys here? I'm not providing anything of value to the betterment of society. There we go. These will do. Just banana extensions. Don't we all wish we could get a banana extension from time to time? Why is it always a sex thing? It's always. It just always is. All right, now we get signal, so we can put a voltage all the way over to the oscilloscope and see it. Pirate Software's viewers love the number 7. That's over my head. What's the joke? That's over my head. That's so over my head. I don't know what that is. I don't know what you're saying. Ah! Set off my dog. Yeah, I'm thinking about swapping to this motor, but going from 9,500 kilovolts to 2,500 kilovolts it's a bit extreme. This is like driving down the street and like waving at people and like, you know, lowrider kind of shit. Whereas this thing is screaming at 75 miles an hour with a model that costs way too much and could just destroy itself with one wayward bump. There's a vast difference between the two motors. We're setting up for a test setup here. Setup, test, setup, setup. So that we can punch code into our micro again and again and again and again. I need a shorter USB-C cable than this Nintendo one. Let me see if I can find one. I'll put the Nintendo one back in the drawer. Nintendo, you go with the programmers. That's here. I'm going to find a shorter USB-C. I don't get it either, and I followed for a year. Oh, is that another streamer? Is that what that is? Pirate Software? I don't know too many other streamers, you see. You gotta treat me like the uninformed layman that I am. And then through me, the viewer can discover these things that I don't know without feeling like they have to ask. Common thing. My USB-Cs are suffering here. I've only got long ones. I need a little tiny little shorty one. Nobody has those. No one has those. Little tiny short USBs. I need a tiny little USB. Nothing too flashy. I think that Nintendo one is the shortest one that I have. That's so weird. There's an Ethernet cable over here. That thing cannot be a good one. Actually, I think that one's specifically a programming Ethernet cable. This one's super uber duper long. Where have all my cables gone? What has happened here? What is this? I thought I had one. It came with something else, and it was a decently short one. I thought it was kicking around here too. Let me see here. Let's see. No, I don't think it is. I must have moved it. Where have you gone? Oh, unless it's over here. Hot damn! What do they do over there? Pirate Softwares. Is it like a coding stream? Yeah, the Hype Train world record. How did he con people into doing that? That's intense. Intense. It's like Burning Man. Intense. Get it? Because people are camping at. Never mind. Never mind. Game dev. Oh, that's cool. So they probably made a pretty cool game, and everybody was like, "Look at this shit." That's nice. Must be nice. All right. What am I doing? I was looking for a USB-C cable that was a little bit less intense than the one that I had, but I'm kind of striking out on that. He even calls it the scam train. A lot of people did. A lot of people call it that. Because, yeah, Amazon and Twitch just kind of like shoved this stuff onto our laps and was like, here, do stuff with this. And we're like, what, huh? And, yeah, it's easy to call it scammy because it's very basic psychological manipulation. Like even I know about it, and I'm not a psychologist. I've just seen several of them, but basically it's just, you're like, wow, this is just blatant manipulation. So the first thing you think of is scam. I guess we'll have to use this one. It's kind of a longer one. Yeah, that'll do. That'll do. Gathering all my stuff so we can stream. I need to get a haircut. I don't know if I'm going to do that Saturday or what. I think I'm going to smoke a bunch of meat Saturday. Do something that will kill you challenge. I don't think I can get behind that. I think that might maybe buck up against like a couple different terms in the toss. I don't know. Just a feeling I get. This is our test voltage. We will put that here. Run that right up against the shelf. Under the USB. Right up against the shelf. Just bring us over here. I like OTT. You guys probably know that already. Let's actually lash these two together. Make them a continuous cable. I see. It's just a meme. I understand that it's just a meme, but it's one of those things. Yeah, all these challenges that come out, it's like, hold on to power lines challenge. And some TikToker that knows how to do like basic rudimentary video editing and special effects will do something that's like patently fake, and then people will try it for real and then get hurt. I don't know if that's ever happened. It just sounds like something that would happen. I have no sources, and I won't quote any. What's up, Pyro? How you doing? We're going to do, like, little bit-by-bit microcontroller stuff today, because it's a lot more hands-on and visual and fun than me just sitting here scratching my nose and balls, looking at code. That'll be a little bit more visceral. And then at the end of the day, I can say that I didn't contribute anything to society. Let's see, we're going into this. The funny thing about these BNCs is that you can just plug them in any old way. Or sorry, not BNCs, these banana plugs. You just plug them in. That's pretty cool. Do I have a more structured banana plug thing? I do, I think. I think I have one that doesn't even involve... No, I don't. Actually, that was somebody else that had that one. I need to get one. There's ones that have these like spans on them that go directly to BNC. I thought I had one, but I don't see it anywhere. Yes. Okay, so... Well, this is our solution today. I'm not going to need all that over there. Move that back. Grab this. Attach the BNC. Yeah, you're here kind of early. Super bored and boss is okay for early weekend. Nice. Hey. It's always good when you actually get rewarded for getting work done instead of assigned more work. Endless pursuit of profits has kind of lost sight of that, huh? What happened? Did the song end? Song ended. Okay. All right, let's see here. How am I gonna... I want a nice clean test setup today because we're gonna be punching code into stuff a lot. So let's get the circuit boards kind of out of the way. I'll put them on the top shelf and just leave an example. The examples can stay down here. These just go up top. I'm nervous about these circuit boards, about whether or not our filter will allow us to get audio frequencies from PWM. That's my primary concern right now is whether or not I've wasted my time. Let's get all the bits and bobs on something. I don't even remember where these screws came from. I don't know. Yeah, it's good to have a boss that like gets it. kind of gets it. Gets why you're there. I ain't here for the embetterment of the company. I'm here to put food on the table. So happy to be friendly, but let me leave. No, you have to be at work at all times. I had a boss that was so tone deaf. A friend of ours died in a motorcycle accident, and I told him about it. And he told me a one-up story of his friend dying. That was one of the most surreal conversations I've ever been in. I'm like, this motherfucker is one-upping my story. I didn't really know the guy very closely, so... But a lot of my friends were very good friends with him, and if I were around at that time in my life, I probably would have known him much better. I actually know his parents a lot better now. But that was all water under the fridge. Still, man, that's such a tone-deaf thing. Microwave charging? What's that? Microwave charging a phone? Oh, to be vague, there was a meme that looked like it came from Apple that said it would charge a phone with a particular wavelength of the electromagnetic spectrum. Oh yeah, those incredibly fake 4chan things designed so that people would destroy their phones. Oh, I gotta get in here. Move, get out of the way. Shouldering past chat. Ugh. God, this place is such a mess. Curse word, it was very difficult to not utter. Ow. Okay. All right. That's a... Oh. Ooh. Ow, 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 ow. I just put in an insulin pump, and it's in my side, and it's in the part of my side that flexes a lot. This one might be doomed to fail. Ah. Ow, ow, ow. Sometimes the plastic tube... Ah. Ooh. Ah, ha, ha, ha. Oh, that feels great. The plastic tube under the skin shifts and hits a nerve cluster, and there's a nerve cluster right by that fucking tube. I just pushed on it and I got like incredible shooting pain. Eventually my body will get used to it and it won't hurt anymore, but I'm gonna maybe try not to move my torso at this point. Ow, I knew that was a bad spot. I should not have gone for it. I might have to call this insulin pump a wash and throw it out. That's one thing that I dislike about the ooh, this is gonna hurt me a little bit. That's fun. Fun. Good times. Ugh, I don't want to have to throw out this insulin pump. Whew. Yeah, that was a shockingly tone deaf experience in my life. Okay, USB cable, power cable I was going to work on. I don't really have a modular power cable. I guess I could probably cook something up at some point with 3 BNCs or 3 bananas on one end, and then yeah, I probably should, given the regularity with which I have to fix people's shit. No, that's not how this pod works. These pods inject the tube only once. There's no way to undo that. There's a little here. It's the I miss farting. Oh yeah. We're gonna get to that, man. Rest assured, I will get that running. I promise you this. It's a major component of Burn the Sub. So when I finish this VCO, I'm gonna work on getting Node Red to do channel point stuff. You guys will you'll get your day in the sun. Is that how that phrase goes? Where's thermals? Why are thermals not here? Oh wait, no, this one doesn't have thermals. This is the microscope view. I was like, what, did you eat a bunch of peanut butter? Like, what's going on? You just come into a stream and go, I miss farting. I challenge you to go into somebody else's stream and just say that. Actually, Robos would be totally fine with that. I miss farting. Yeah, so the pump, right? It has a one-way barrel that is operated by memory wire and a little thing that goes back and forth and sort of advances that barrel. As that barrel advances, it releases a mechanism that throws a syringe with a plastic tube around it under your skin, and then the syringe itself retracts, right? And it leaves behind this little plastic tube. But if you put this on an area where your body's flexing a lot, this tube can do a little bit of movement in and out of its little hole that it has going under the skin. And so what happened, I put the pump, the one that I just put on like 10 minutes ago, it's on my side. It's on the side right where I guess my pear-shaped body meets my rib cage. And oh fuck! Okay, hold on. I'm gonna actually punch it. I'm gonna hit it. I'm gonna hit it and press it up against my body. Oh my god, that's a lot of pain. Whew. Okay, so if my body can get used to that, my brain will start ignoring that. Once my brain starts ignoring that signal from those screaming neurons, I'll feel a little bit better. But right now, it just feels like, I don't know, like a bee sting in my side. It's pretty bad. Fucking sucks. But people learn to ignore bee stings. Yeah, I put my pin header on the 2500 kilovolt motor, kV motor rather. It's not kilovolt, it's kV. But the 2500 is now loaded and ready, so if I want to put it into this frame, I can, but it'll feel more like cruising around than it will going fast in race car. So I'm a little reluctant to try it out. I want to get this thing outside running full speed. But it rained today. Screaming Neurons is a pretty good band name. Yeah, it's pretty good. Hope you get used to it quickly. It sucks. It just happens every now and then, and the unreusable nature of the Omnipod forces me to have to grin and bear this. If I was using the T-Slim insulin pump, I would simply get out a new pad. The pad with the piece of plastic that goes under your skin, that can be replaced on a traditional pump, one that goes on your belt. But I wanted to try out pods, and I'm liking it a lot because there's a lot of automation involved and not a lot of equipment hanging off of my body that I have to worry about. But on the flip side, it means that if I do change pods, this entire pod is bupkis. There's also actually T-Slim, the same company that made my old pump, is working on a pod-like system where you have a patch that the pump clips onto, and you reuse the pump, which I would get behind. I'd very much get behind that, because it's so much more economical than throwing away all these electronics constantly. Allergic to stings, but I was diagnosed after being stung in the face. Oh my God. Every now and then I get stung in the foot. I'll have less of a reaction. Damn. I haven't been stung by a bee in a long time. I'd be concerned about my ability to handle whatever shock that gives. I mean, as you can see, I'm good at disassociating pain, but still. I've become very good at disassociating things that are extremely painful. Fucking nurse slipped out of the vein. We got a full minute until this thing boots up. This is way too long, actually, to be honest. But it's way too short if it's just this. I guess that can reach, so maybe we'll do that. Went through all the trouble to find these banana plugs. I think I'll put these back on the... Yep, Kurokesu C920. It's in the scope command. Exclamation point scope. It is quite wonderfully useful, and it's something that I had to develop on my own. I don't know if other streamers are using this setup or not at this point. I know scientists use this kind of setup, but I don't know if other streamers are using this. Less of a need for that now. What, are there actual like webcam? How's the new internet? It's okay. This I did a speed test on this machine and it was abysmally slow. So I don't know what's up with that. The download was like 400. But the upload was pretty bad. So I bought a bunch of Ethernet, like long run Ethernet cable, and I'm gonna rewire my computer desk, and while I'm back there, I can take a look at how the stream computer is. A document cam used for scanning books. I don't know, I like how rudimentary this thing is. It's nice and easy. But I don't know if other streamers are using this setup, because I've been suggesting it to everyone and their dog. Everyone and their dog has had this recommended by me. But yeah, I started out with an RPi cam, and I had some rudimentary microscopy kind of stuff going on with that. And that didn't really work out because of the delay. Delay in a microscope that you are soldering with is hazardous, to say the least. Hazardous in that you can poke your finger with the soldering iron very easily when there's too much delay. Very easily. Poke of the finger. Do you have one of those setups where it puts like a wedge into the book and then takes a picture? So yeah, if I can get back in and do a little bit of recabling, because I have like keyway adapters and stuff like that in the path, and I think that's affecting internet speeds. Pretty much every computer in the household now gets about 100, right? Because all of the things knock you down to 100 at like a moment's notice. When it sees any noise at all, it's like, ah, you're 100 now. It's like, wait, no. Okay, power. USB, oscilloscope, modulated mod. Let's get this on a device. Kurokesu Logitech cams are sold out. Just the shell or the whole thing? I mean, I don't know what that area of the world is like at this point, and I was concerned about getting the one that I have one more of these cases and one for the C920. This cam, and I plan on putting my old this cam into one of these. We just ran into a problem where the DRO doesn't work, and so I couldn't do that little bit of machining because I want to keep the original focusing optics on that one. So I'm all stocked up. Okay, let's see. What else do I need to prep? I think I got everything covered here. This would be our voltage input that we're going to test out with the O-scope. Beautiful. How are we doing today, everybody? Yesterday was fun. I had no idea Uo's lab would stop by. Uo's lab. Buy sensors directly now. Not much need to mod webcams. You can get sensor boards. Huh. Voltage source, we can go into one of these two. And then observation of this is not necessary at the moment, so I'm just going to put this away. We'll just get that off of there, actually. I should probably put the BNC cables, the short BNC cables, up to the scope instead. Yeah, let's do that. Let's do that instead. Oh wait, no, but it's not the right type of BNC cable. Never mind. Not the right type. Sure. Yeah, go ahead. Link us up. Take a look. Banned for sharing a link. Holy shit, look at that thing. Wait, but what even? I mean, like, that thing is awesome. It's a science cam, so it's going to be really expensive. That looks like a Fusion 360 model. 193, Jesus Christ. But you don't even get like optics, like how do optics attach to that thing? Does it focus on its own? This song is very cool. I can get a 3D model for it so I can fully plan it out. Damn, son. This song is very cool. CS mount. Because they show it with this big lens in there. I don't see anywhere you'd mount. No, this is OTT music. And the album is called Heads Full. Or no, sorry, it's called Heads. Song is Holiday Boat. Yay! Yeah. Yeah, OTT has good stuff. Good stuff, good stuff, good stuff. Okay, let's see. So we got that going for us. We got power. I guess I can plug this into power. We didn't have any power blowouts, so that was good. The only mistake I made was putting the power connector upside down in my design. That was a fundamental flaw that I could have avoided very early on. And then alternatively, I can put 3 volts into this if I need to. Or actually, I could run jumpers from here to here. Probably the way we should do it is just run everything off of this at once, because we're going to do some of the hardware testing, and then we're going to put little bits of code into this thing in order to make it do stuff. Australian Power is just you plugging it upside down. You know, I guess what they figured in the States is that they would make all of the plugs upside down, so that if you had like a fork and knife and it accidentally slipped behind the power thing, it would hit ground instead of a live thing. I don't know to what end that saved or hurt people, but we flipped all of our plugs upside down. I don't really understand that very much. Because all kinds of things can happen. Let's see, here's all our theory. Here's Hagiwo's YouTube. You guys should check out if you're into modular synths. And then we got our code. Got too many code windows open. I'm going to close. Well, I need to keep 2 of them open. super duper fucking cool song. Good lord. It's called Holiday Boat. It's by OTT. Fuse boxes. Yeah. Where's the scope? Bonk. Turn that off for the time being. All right. Put this like low enough so that you can see the front wheels. Put it like there. There's already a little vertical for it's for mounting a body, but I could probably use it to mount this cam just like right like that. I think there's a Thingiverse model of this, so I can actually 3D model some of the parts that would go into making that. Just a little FPV carrier. So you see the front wheels, and they actually, well, if it was Mario Kart style, it would probably be here. Like there. They have motorized lenses and manual lenses. That's so expensive. I like Kurokesu because I could get it relatively cheap and then modify my own webcam. At some point. Louis from Lunatic Live, also from Djibouti Show, convinced me to get this little FPV camera. He's like, yeah, they got these little ones that are super cheap. And so I bought it, and I'm like, this is cool and all, but like, I haven't done anything with it yet. And I've got my old FPV goggles that give you this little tiny picture in the middle, and they speak to this frequency, so I could take advantage of that. This thing gets hot as hell, though, when it's operating. It's very, very, very warm. But that would give me a little FPV on the RC car. I don't know. I don't know if I can stomach going outside with FPV goggles on. You know, being that guy. Mommy, what's that weirdo doing? Don't look at him. I feel like we can take these down to coefficients and have a wavetable equation like function that's a little bit more universal and would clean up a lot of this stuff. But it's going to take a little bit of code manipulation. So I think what I want to do today is I want to make sure that all of my hardware works so that I can go full bore into this code and we can bring functional blocks over from one code to the other. Have my nerves calmed down? A little bit, actually. What are you poking against? Jesus Christ. There's like a cluster of neurons or something, and this tube is just like, hey. That means that when I'm sleeping, if I roll onto my side, I am going to get a wonderful little injection of horrible pain into my body. And the problem is, I don't know if what I'm feeling is the tube having slipped out. I've had very bad luck with my side. Well, the next 2 days I'm going to have this thing in, and then I'm finally free from this. And I can put it in a different spot. I got to figure out what a different spot is. I haven't done any legs or buttock. Legs and butts are the places where I haven't tried the pump. I've done my stomach and sides, and I've done arms to within an inch of my life. If you inject too much insulin in one spot, you get a growth area, because insulin is a growth hormone, so you get kind of a rubbery piece of, like, it feels like there's just rubber under the skin. Those eventually go away, but still, I've got a little bit of that on both arms now. I've done arms for a couple weeks, so I need to do legs again because legs are a much larger muscle, and the insulin can disperse over a wider area. Oh, I had a USB-C cable right there. That one's a little long, though. I think it's the same length as this one, to be honest. It's a fancier one. We should use a fancy one. I'll be able to see it on the desk easier, too. I hope this one takes data. I think it does. Oh, it's a USB-C to C. Never mind. Never mind. Go back over there. I use this, Amazon accidentally sent me this instead of a dog toy, and this is worth $75, so it's going on my scope. It's the nicest power supply, USB-C power supply that I have. One of the few times Amazon came in clutch with something I didn't know I needed. I need to get a haircut. I'm like, where is oh bother? I'm just like, yes, I'm hiding in the bushes. There's no me left in here. It's all hair. Yeah, I think as the weather is turning, I need to get my hair cut. I'm not like Groovy something. I can't just like set a buzzer to number 2 and just go over my entire skull. I need to get my hair styled. There's a stylist near here that I need to go to, but they should rue the day that I walk in those doors. I'm here to deposit hair. Lots of it. Let's see. There's not a lot of Twitch drama going on at the moment, is there? Not a lot of Twitch drama, unless you actually specifically seek it out. There's no major things going on, which is always nice, but who knows what the hell's going to come down the pipe next. What unreasonable thing is going to strike us. Cutting my own hair is a pain in the ass, but damn if I won't pay for a buzz cut. Seriously, like if I could do just a buzz. I mean, by all means I can do a buzz. It's just I would literally lose viewers if I did that. People would tune out because they're not used to looking at what I look like with a buzz. I've never had a buzz actually, but I have glorious hair and I need to exploit it for all of its worth. But it would be nice if I could just cut my own hair, just cut my own hair. I could do that. Would actually be a good stream if I didn't have social obligations of looking okay. It would be kind of funny to do a engineer learns how to cut his own hair via YouTube stream. And I'd be looking at these instructions like, how the hell am I supposed to clip? And I'd look like shit afterwards. Cutting hair can't be all that difficult, can it? I mean, as somebody who likes to work with their hands, I don't know. I had a buzz cut all the way up to middle school where I got the trendy bowl cut. Oh God, the bowl cut. I used to do the bowl cut too. It was horrible. I used to actually have white hair because it was so blonde, and in the summer it would bleach from the sun. Of course, as you age, your hair gets darker, so here I am with dark brown hair. This cable will not cooperate. I try to coil it up and have it kind of retain a little bit of a coil, and it's just fighting me. 2 mirrors and have awkward reaching behind your own head. Oh God. Listen, I'm a demon with scissors. I can do okay stuff with scissors. I'm dexterous. I'm Dexter's Lab. Can't put the power cable a little bit further back. But we got to plug into these back here, so. Sus. I know, I can't exactly prove it. Do I want to look forward to one day having dark brown hair? My grandparents all had, except for my grandfather on my dad's side, had thin white hair, and he was mostly bald. My grandmother had great hair. My mother has, well, she has white hair now. My grandfather on my mother's side, big full head of hair. Grandmother on my mother's side had curly red hair for a long, long time. I don't know. I think I got good hair genes, so I don't know if I'm gonna go gray. The beard is starting a little bit, just a little bit. I've got a little bit of that going on here. For a while, it was like one single hair would go gray, and then I'd pluck it, and that would be the end of it. But it looks like the bottom of my chin here is gonna start salt and peppering as I enter my 4th decade. I don't know what's going on with the stash. That seems to be lightening up a little bit. But my head, I don't suspect will go peppery at all. I think I'm going to stay brown for quite a long time. So if I do get to Doc Brown levels, as you can see, my hair does not stick out. So it's not thin enough to stick out. It's thick and oily, so it doesn't, and it's very clean. I wash it every day. but it's not going to do a Doc Brown. Oh, that's the end of the album. We might as well start then. Bop. Hi, hello, it's me, Oh Bother Slab. Yeah, welcome. So we're still working on this VCO, and for the life of me, I can't stomach any more programming. I mean, I can, it's just meh. So what we're gonna do is we're gonna refocus the programming efforts a little bit here. There's a lot of stuff that I want to do with this code, and it seems like stuff that I should probably do off camera, because we had an entire just straight up coding stream, and I know some of you freaks are into that sort of thing, but I lose viewers with that sort of thing. So what I'd like to do is take more of a meat space approach to programming and take a look at the functions of the board. We can look at the hardware and make sure that everything's working properly on the board that I designed, and then we can start hitting it with just little tiny bits of code that will allow me to test certain facets of the software and make sure that it is viable in the first place. I want to make sure that we don't do too much work in one direction and then end up running into a wall for something that we didn't know. So this common microcontroller stuff, what we'll do is we'll start up a new program, and I'll pull little pieces into that as we take a look at the hardware functioning. But first, we need to make sure that we can program into viable hardware. So we will test the hardware out and make sure that things happen the way they're supposed to happen, because otherwise we're going to trigger that triple T condensed nonsense bot, and that weird viewer will appear in my stream again that for some reason audibly monitors streams. That was a really weird thing to have happen, because I know that person was not watching me out of the blue when I referenced that set of commercials. It was the weirdest thing. A little while back, like, God, I don't know, years ago, maybe a year ago? It might have been just 1 year ago. I said the magical phrase from those Terry Tate commercials, and a user with the, like, triple T or something, like, you know, like a Terry Tate specific user showed up in chat and started saying stuff, and I was like, what the heck? Are there bots that monitor audio on streams? Like if I say, I love Pepsi, will Pepsi jump into my stream and be like, hey, it's Pepsi Gaming? I don't know. Because it happened. Anyway, so yeah, we're gonna do a little bit of hardware on this thing, and we're gonna make sure that all the connections that are supposed to be made are made. So let's take a look at our hardware. You guys know that I've been working on this for a while. I designed a circuit board, maybe a little bit too early in the process, but we made a circuit board out of a design by a YouTuber called Hagiwo, who makes extremely cheap modular synthesizer stuff. And he builds all of his hardware himself on perforated prototyping board. And while I applaud that, well, it's the 21st century. You can get 5 boards for $5 these days. These are a little bit above 100 millimeters from end to end, which was dumb of me to do. I probably could have made the design work with just a centimeter less. That is kind of a significant amount of space, but I think I probably could have gotten this to work if we had the bottom right up there and the top was a little bit closer down, the microcontroller was shifted. I probably could have made that work. It would have been a pain in the ass, but I probably could have made it work. This was not a difficult design. It was just sort of a normal difficulty design. There's a little bit of room for all of the op-amp stuff going on down here. We added a bunch of op-amp stuff. Hagiwo, in the interest of keeping things cheap, uses a lot of very small passive kind of ways of getting your 10 volts into a 3-volt microcontroller, but I wanted to be a little bit kinder to all of my hardware and make sure that there were actual, like, things blocking the path of high current going into the micro. So what we have is a design from Mutable Instruments, who does, I believe, about the same thing with their audio output. It's basically you make an inaudible PWM and you put it through a filter, and that turns it into audible sound. It's been described as similar to dimming an LED. You put PWM into an LED and you can make a dimmer LED with that PWM. You're not cognizant of the individual pulses because your eye has persistence. It has kind of a filter on it. that's sort of a way to explain how this Sallen-Key low-pass filter turns inaudible PWM into audible audio audaciously. I don't think that's a word. Anyway, so yeah, that creates audio. We haven't tested any of this stuff, and the mutable instrument circuit that I got, I was like, I think that does the right thing. It was like low-pass filter for PWM, and I think it was to get rid of, like, I don't know, it said low-pass filter for PWM, right? And I didn't even know that this scheme used inaudible PWM to make audible noise at the time. I just took the circuit. It might be perfect, but it also might be totally the wrong thing, because the STM32 that Mutables uses is a little different than the RP2040. I don't know if it's making audio using PWM. It would be nice if that all worked out. There's one way to test it, and that's by looking at the hardware. So let's get to vetting this out. I mean, like, it was an incredible gamble that I took, and I didn't even intend to take it. I thought, in my brain, somehow magically the RP2040 was outputting PWM that was at audible frequencies, and it just needed a little bit of filtering to make it sound clean, and then amplification to put it up to modular synthesizer voltage. Whereas on the Hagiwo circuit, it is making inaudible PWM, and that the filter is making it audible once again. So we're gonna have to work this one out. But anyway, that's what all these toys are for. That's why I have all this stuff. Well, not that toy. That toy's not for this. But that's what all this stuff is for. That's why we have all this setup here. If you guys want to know what my setup is, we basically have a high accuracy Agilent power supply. This is not the one that I made myself. This thing I trust with most tasks, but this thing is good for audio tasks, because when you get into analog electronics, you don't really want to leave a lot of stuff up for interpretation. You don't want to have sort of an, oh, this is kind of within a certain percentage of the voltage that I set it to, or, you know, within the standards for this type of, let me get the soldering iron wire out of the way. I am very serious about my test setups, chat. I need to have a clean desk, and I need to have everything nice and orderly in my setup. And this may look like a mess, but it is actually quite orderly. The reason behind that is wasted time. You can waste your entire day to a messy setup. So it would behoove you, if you are getting into testing of your circuits and electronics, to stop, clean up, clear your head. Take a break, come back to it, make sure everything is nice and orderly, because the disorder and chaos will cause sparks and fires. So, ever play Half-Life? If somebody says the limit is 100%, it's 100%. Don't go to 105. That's not true. That's not true. That's a lie. So what we have are test leads, solderless breadboard, microcontroller, and our built circuit. I have the power supply hooked up to the Agilent plus minus 25 volts. This is also the only power supply I have that does plus minus voltage. Otherwise, I'd have to build something. If maybe at some point I figure out that, you know, hey, maybe I should make a module testing module and build in that cheap oscilloscope into the thing. That would be kind of cool. Then I'd have a little box that has a graph on it, a little O-scope chart, and all the voltages would be available on the thing. But that's not the reality of what I have right now. I'm not going to embark on a whole odyssey in order to create something like that. Instead, I have all of my normal test equipment here. And the normal test equipment needs to go to plus minus voltage. So we use the Agilent power supply that can do that. And then we also have a 6 volt, pretty high accuracy 6 volt power output here. So we can use this to make our -5 to +5, or we could just go 0 to 6, because that's the limitations on it. And then that way we can punch current into this thing and see what the results are on the microcontroller pins. All right, so pin for pin, I guess we should just get started here. Now, when I power this thing on, everything seems to come up to power properly. We can measure the power too. I guess we'll use the scope as a multimeter. Currently, this one is on what bank? Here, let's put the scope on the screen so that you guys can see what I'm doing. Where did it go? There it is. Bonk. There's our scope. And let's see, where's chat? Chat, I think you guys are down there. Let me move the scope, actually. Well, actually, you know what? In the upper corner, I think that's okay, because Actually, it should probably be in the upper left corner. It should block the actual scope. Just like that. Well, then you guys can't see me twiddle my knobs. That's fine. We'll do it like that. Okay, so there we go. You guys get a nice big scope readout. This is like the least readable font ever, or color combo. Okay, what do I hit for that? Channel 3? No, that didn't do it. I need to edit the edit this right here. So measure menu. I don't think that's right. Wait, I should be able to close this. Is the touch screen going weird on me? Yeah, something weird about the touch screen. Oh man, I was able to poke this before. All right, so what menu is that? Well, is it a cursor thing? Oh, that's wave intensity, okay. What's that one? Operation disabled. That moves our scope up and down. I need to get into, that's touch lock. Run, stop, analyze cursor measure. This one is result menu. C2 is measuring frequency right now. Horizontal menu, trigger menu, I don't need. I gotta learn how to use my scope again. Come on, start menu. This thing's being weird about touch. It's like, am I in something, or is something weird going on here? Because I can't select stuff. But when I pulled up that menu, I was able to actually touch things. Logic analyzer, reference, don't need that. Hello, don't need that. All right, what's going on with this thing? Yeah, this is the new scope. It's pretty crazy. There's a lot of cool features on it. Right now, I'm having a little bit of trouble with the touch not really recognizing me, though. Yeah, the touch screen doesn't like me. I mean, I could open the interface from the web. I could literally go to, hold on, let's see. Oh, wrong thing. I can open it on the computer. That was a birthday. The scope was a birthday gift for being an ancient person. Rigol. URL. What was that URL again? It doesn't really tell you, does it? There's an intranet site that I can go to that'll bring up the scope. No, that's all my lights. No, I forget what it is. Like local host or something like that? Like Rigol. Products, not shown, localhost, scope of the PC, web control, Salesforce website. Oh wow, that's okay. So the pump is injecting insulin right now, right directly into that nice little pain cluster that I'm getting. There's like a URL. What's the URL? Blah 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 blah. Web control button. I mean, yeah, I can do it by IP, but I can also just do it by. Oh, you know what? It's in OBS. Let me just look at the scene for the scope. So scope goes to what web page? Let's see. Properties, and that's. Oh, it is a URL 192.168.2.2.2.2/control. I think 2222 is actually reserved for something else. Weird. See, like here I'm able to click on it. But when I click on the touch screen, it's not recognizing me. I need to calibrate the touch screens or something. Power status, beeper, aux out, input lock, off. Other, auto config, keep coughing. Please disconnect all channels for self-calibration. Screen will display different colors. Please check whether there are black spots. Oh no, that's not what I wanted. I wanted touch calibration. Well, I guess we can look for dead spots. I don't see nothing. I don't see nothing. I don't see nothing. I don't see nothing. $60. Yeah, it's a little warm, but that's okay. Oh, I can't go back from here? Uh-oh, that was the wrong button. Utilities. Touch test. I mean, that seems to be working. Okay, so it's not me, it's something else that's... it is me, it's not the scope. I like how my brain default said, it's not my fault, even though it is my fault. Oh, it's just these areas. Are these the only places that you have touchability? I'm gonna fill in all the boxes. I'm a good boy. Yeah, I did it. Exit. Why does it not let me hit exit? Yeah, the start button blunk when I touched it. If I'm in here from the computer, I wonder if I close this and then I go to this scene and I close this, do I now have control again? No. Why isn't it? Wait a minute. That's really weird. I should have, by all means, I should have full control. We didn't have this problem before. Time to call Rygal. I've already violated the warranty on the scope tenfold. But I don't think that's really what's going on here. Because when I do the touch test, it's totally fine. See, that pulls it up immediately. That's really weird. I don't know what's going on. If it's like locking me out. Is it like some kind of a setting that's locking me out? And there is actually a touch lock button. You had to stop streaming to get the knobs working on it again, or else it's locked. That's not what this one does. The knobs do still work. It's just I'm thinking it's along the lines of what you're saying. Because like you guys see, stuff is like flashing as I actually hit it. That works. Run stop? No. But like if I close all the web interfaces out, weird. It totally, well, it did it. It just acknowledged my touch there. But yet, we had no trouble with this earlier, by the way. On the old one, I was able to grab the start menu and like manipulate it, and it was totally cool with it. And it was showing it while we were streaming. So that's why I feel like something I hit has moved me off of wherever I need to be in order to control stuff. And yet the scope appears to be working perfectly fine. I just want to change our multimeter view so that we can measure some voltages on this thing. That's true. LAN disconnected. Yeah, so I guess it's not the streaming that's affecting it. But when I put it through that test, the touch test, it was perfectly fine. This is weird. It tested perfectly fine, and then when I go to poke the screen, it was bad. It was bad. Everything about it was bad. Cursor menu comes up just fine. Analyze menu comes up just fine, but I can't close it by touching it. And I can't... Oh, that clicked it. Something in the center of the screen actually clicked. Am I, like, grounded weird? What if I stand up and press it? Why am I cursed? Why am I cursed? The EV blog forums suggest a factory reset. That sucks. All right, I'm gonna get back into this thing with a mouse. Actually, we should, I mean, listen, troubleshooting 101, right? Turn it off, turn it back on again. It's like I didn't do anything with the scope. It's running just a little bit warmer than it probably should, but other than that, I mean, it's cool in this room. So let's just try turning her off and on again. Oh, I can't even turn it off. Just hold the button down until it dies. I'm sorry to have to do that to you. It's possible I could also clean the screen, but we saw it pressing stuff, right? So I don't think it's a touch calibration thing. It's just it's not listening to me for some reason. You could turn the touch screen off, but it wasn't off according to this thing. So push comes to shove, I can do a factory reset. It's not like I've set a lot of custom stuff in this scope. I want to get to testing this thing. We got a lot of hardware to get through. I need this thing to be a bit more reliable than what I just saw. Now there's all kinds of weird stuff going on. Now it works. So turning it off, turning it on again apparently did the trick. Now let's open up the scope on the LAN and see what happens. Okay, now it's responding normally. I do not know what I did. But now it works. So yeah, turn it off, turn it back on again. So let's turn our scope onto channel 1. That'll be a bit easier to see too. Now we can see voltage on there, and what I can do, well, we got to set up the Agilent power supply. Now setting up the Agilent power supply, it's important that I unplug. There we go. That I unplug. I've been around the block once or twice when it comes to troubleshooting. I've been around the block. So I'm going to unplug this, and then I'm going to go to the Agilent power supply. And then I'm going to go to the Agilent, and I'm going to go to the Agilent power supply. Turn that on. Luckily, this thing is made in the early 90s, I think, maybe the late 80s, and it just turns on. It just works. ToddHoward.exe. Unfortunately, the thing about the Agilent power supply is that you have to turn it on in order to set the voltages, which is kind of stupid. You have to turn on output. So Plus 25 volts, we take up to 12. Minus 25 volts, we take up to 12. And then 6 volts we're going to leave alone for right now. So now we have power shooting out into this thing. Were this the first time power up of this system, my ears started ringing. Setup, arm procedure. Things are looking a little too bright. Yeah, there we go. I didn't calibrate my Logitech camera. That's still a little bit bright. So now we have 12 volts going into this thing. If this were the first time power up, I might want to current limit my power supply so that I'm not getting way too much power into my circuit. You set it to like an amp, and that'll keep you from blowing anything up. But because I'm haha funny man on the internet, I need to have it at full power. So we plug it in, and we observe. Oh, thermals. Something went wrong with the thermal cam. All right, unplug it, plug it back in. Go to properties. Take some nutraceuticals. What happened? It's not working at all. Yeah, wiggle the cable a little bit. I have a white LED on this thing, so it should. We'll deactivate it and we'll activate it again. There it is. Cool. So now we have thermals. We can see how warm the scope is, but mostly I'm looking at the module here to see if there's any intense heat. There really shouldn't be, because the only thing that's being powered right now are these two, and we are drawing 0.001 amp. So that's pretty good in terms of current draw. Now we can take our probe, and I don't need the ground pin on it because I plugged one of the headphone cables into the back here. I guess I'll move the scope over to the other side just because you guys don't need to constantly see the power supply. Let's see, where's that scope? Scope, right there. Move that back over here. I know chat's going to be on top of it, but it takes up a lot of space on the screen. Now, there's a bunch of space in the bottom corner, but still, anyway, okay, so let's check to see what we got coming out of the power supply. No? All right, what pins are, let's go to the RP2040 pin out, which I've still got open right there. Whoops, no, I need that. Come back. The dog's barking at something. Okay, so on the right here, we have 5 volt ground and 3 volts. Now 5 volts not gonna be powered up because nothing's connected to it, but we're gonna look at that 3 volt pin. So that's the third pin down right here. And by all means, we should be seeing 3 volts. So if we don't, something might be wrong. Let's check the diodes. Negative 1.1? What about you over here? Okay. Come on, buddy. .07. Is this stripe is on the right? Yeah, stripe is where the stripe should be. So that should be positive and negative there. And then the big guy is minus, and that's down there. Wait. No, the big guy is up at the top. Yeah, that's right. Oh, ground wasn't really connected. Let's check that now. Still not doing anything? I thought we solved this issue. This is a setup issue. That's what this is. Yeah, this is a setup issue. So what's going on here? When we looked at this, the diodes were... It wasn't the diodes, it was the cable that I built was backwards. It didn't work. This one is frontwards. This one is fine. This should be negative 12 volts. It might be that the scope just doesn't work as well as a... Well, that's... Why is it so spotty? What's going on there? That's just noise. What the heck? Hey, what's up, Walrus? I know the PSU says -12. That means we have -12 from our ground reference. This is ground reference right here. This one should be at +12. But all we see is noise. So why aren't voltages getting to the output here? Output on off, output off, output on, +12, -12 on the ±25, and that's this over here. So that should be perfectly fine. These three over here should be connecting. It could just be that this thing is not measuring it the way I want it to. The coupling should be DC, and that should give us the voltages that we're seeing, but why aren't we seeing... I mean, that's... Okay, so this is at 10x, now it's at 1x. But it's still seeing crazy noise. So it's possible that I need to ground this. It might just be that the scope doesn't share grounds. So let me get a nice long lead here, so I have a little bit of freedom of movement. Just throw this onto ground. It's weird because the old scope, if you grounded one of them, they would all ground together. No, apparently they do. And we're just getting weird, wacky noise. Why are we getting wacky noise? What are the settings of the scope? Fine off, scale 5 volts, probe. That's a lot of logic going through there. Coupling is DC. We don't want AC coupling because we're not measuring AC. Label off, invert off. Everything should be totally fine. So why then am I not getting power at the power cable? Measure it all the way over here. Why is everything noise? What the fuck? What's going on? Why has everything failed me? Why do you betray me? Why everybody betray me? Is it because we're coupled to the 6-volt side through here? Nope, not quite. So where's the problem here? Let's check the multimeter. Let me do this guy and see if this will come up with something. -12. Yeah, so we're seeing the right power everywhere. That's got 12 volts on it. Just for some reason, the scope wasn't reading anything, even though I'm theoretically coupled with ground on everybody. Why would... What is the 300 volts on these? So why am I not getting a measurement? It's not DC coupled. Or it's not AC coupled. I don't need AC on that. Fine off, display on, channel 1. No bias on it, no inversion on it. Everything else is like standard. So we should by all means be seeing power through this as 12 volts like we did before. Instead, we see that, which is wacky. Why are we seeing that? Is it my setup? I don't think so. It's easy as can be. We are literally measuring a wire that goes back to the thing. Huh. What the fuck? Like, do we still not, maybe it's still not a ground properly? No, all the pins should be grounded. All the pins that should be grounded are grounded. So by all means, and between ground and there, we're seeing a weird set of voltages. What's going on? Like, I can't really get into the, I can get to this. Brr. That one's got nothing plugged into it. This one would be brr. Oh no, the one on the end. Yeah, there it is. It's wiggity whack. Yeah. It's wearing all its clothes backwards. It's crisscross. I can't really think of what's going on here unless it really is. It shouldn't be AC or DC coupling. DC or AC is when you have the wibbly waves going on. If I flip this to AC coupled, what'll happen? Let's see. Just for shits and giggles. Will this actually be able to measure 12 volts now? Nope. Nah, it still has the same stuff going on. I mean, I'm trying to measure positive 12 volts, and you can see right there, it's on the scale, so it should be coming through. Is my probe broken? Try a different probe. I don't think my probe's broken, but there's always a possibility. Oh, you know what? I'm not getting a ground. Wait a minute, I'm not getting a ground because this isn't plugged in. Ah, that's dumb. Okay, that's what it was. This is not getting a ground because the other end of the plug isn't plugged in. So going to any of the other pins on this doesn't actually give me anything. So that's what it was. It's not ground coupled the entire time. So now we have a reference to ground, actual ground, instead of a pin that should be ground. Let me put the probe back in. I'm sorry I blamed you. This thing is back on DC coupling. No, let's put it back to DC. And then I guess I do need to plug this ground in because we're not sharing grounds between our probes, which is weird. And then if I go to here, go to here. There we go. Positive 10.11.9, 12 volts. Okay, so (2013). Now if I plug this in, I should be getting 3.3 volts right here. And there it is. We take a second for it to propagate across the entire screen, and then it shows 3.3 volts. Okay, cool. So we've got the right voltage. So we got 3v3 going there. These should have, I think we've already tested this, so these should have a certain amount of volts going to them as well. There's our 3v3 going to the MCP, and then 12 going to the TL074, plus and minus 12. So that has 24 volts total available to it. In terms of heat, there's no heat, which is good. Nothing has gotten toasty. We see a little bit of heat on some of the components. It's just the scope is like burning up behind it, so it kind of biases things. Okay, cool. Cool. So now we can plug 6 volts into our CV input. And the CV input that we're looking at right now, CV in goes to P26. P26 is A0, and it's all the way up here. And so now we can see the effect of putting 0 to 5 volts into the CV input. So right now we are at 0 volts, so this pin should be at the midpoint of 3.3 volts. Look at that, there it is. So 1.6. 6 and 6 is 12, 1, 1, 1, 3.2. So we get the 3.2 volts with whatever setup we have. So if I go to my plus 5 volts and I start giving it the beans, 1 volt becomes 1.5, 1.3, 2 volts, 3 volts, 4 volts, 5 volts. So as that goes up, the other one goes down. And we can actually scale channel 1 a little bit more appropriately. channel 1. There. So now 3 volts is all the way up top. So 4, 3, 2, 1, 0, -1. Oh, this doesn't go into the negatives. If I flip the leads, we can get up to 3 volts. But look at that. So that's the relationship between input voltage and voltage to the microcontroller, which may mean we need to invert stuff, because I don't think Hagiwo's code does this. I don't think it does this inversion, but this is the mutable instrument scheme. So if I flip my leads, I go up 1, 2, 3, 4, 5. We get up to 3.3 volts. How cool is that? Flip it. Three, 4, 5. So that works. Cool. So first CV input works perfectly. Oh, it's nice to actually have something work for once. All right, so now let's flip over to the second CV input up here. This one is connected to P28. P28 is the third one down here. And at 0 volts, we are sitting pretty at 1 point, should be 1.6 maybe eventually, 1.3. These will have a little bit of bias on them. So now we go positive. 1, 2, 3, 4.9, 3, 2, 1, 0. And then we flip the leads. 1, 2, 3, 4, 5. Oops. Well, it looks like this one saturates a little quickly. 4.9. No, I guess it's in spec. All right, so that works. The octaves, aren't they plus minus 10 volts for the 1 volt per octave? I guess we'll be limited in the number of octaves. We'll only have 10 octaves available to us. Wait, no, but that is 10 volts. -5 to +5. Yeah. Okay, I know what I'm talking about. Cool. Okay, so those are the 2 CV inputs. We can take a look at some of the other ones too. We can look at, and I need, well, no, I don't need, I can just look at this. P27 is this potentiometer right here. So P27 goes to this one in between the 2 CV inputs. So it's this one right here. And then I can go here and I can go doodly doodly doo, woo, 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 woo. Look at that. Woo. Okay, anyway. So I have the full range of voltage available to me here. Go down to 0 and go all the way up to 3.3. Wait for that to propagate, 3.3. The only thing about using this as a multimeter, the scope as a multimeter, is that it's not very responsive. Here's this one, positive, negative. Good on you. Perfect. Okay, cool. What happened there? Did I slip? I must have lifted off of the thing, yeah. Okay, that's those 2. And then the other ones we're not really going to be able to observe, like the buttons and stuff. Pretty sure those work. And the LED pin, of course, is just like a simple LED pin. So those are very basic. Very, very basic. So the other thing to test is audio out, but audio out needs a PWM. So we need to actually create something in the microcontroller that's going to give us a PWM, and then we need to observe the output. So I can turn this off, and I guess I can move this over as an input. Or no, that turns the whole thing off. I guess I'll just unplug 6 volts. We'll just monitor 12 volts. We have 0.003 amps going through. This will plug into audio out. I need to reposition it. Probably should turn it off for this. So this is the big one here, audio output, measuring the audio output. Because if it doesn't work, we gotta re-strategize things a little bit. This will not be down to probing, so we will take this away. Actually, we might need to probe, so I'll leave it on there. It would be nice if I could find a slightly more powerful, quiet fan for this scope, because it needs just a little bit more airflow. It's running very warm, which isn't a huge problem, but with that fan that I got off of Amazon, the blue fan, it is cooling nicely. It's just the whole thing is a little bit warmer than I would like it to be. So we modded this fan and we got it to fit in kind of perfectly, to be honest. It's exactly the right size, but I wish Hagiwo would use like a real fan size so that I could get like a Noctua for it. It's a bit of a meme that we put Noctuas into everything, but it's also because they are extremely high quality fans and they do a very good job. I mean, I guess I could just take the fan out entirely and put a Noctua on the outside, but they have all these little strengthening things on their little hexagonal grid that are keeping me from attaching a big fan. I mean, I could put like a 120 millimeter fan into the VCO mount screws and just have that on the back running at a low speed, because they undervolt the fan too. They undervolt it a little bit, which I wonder, I don't think that's down to a digital control. I think that's down to it might be down to a resistor that I have to find. How's everyone's Friday? We're hanging out, we're testing circuits. So far we're finding out that most of the stuff that I built is perfect as usual. Par for the course. Yes. I thought this bruise would be going away, but holy shit. Like, can I go back to the doctor's office and be like, look what you fuckers did to me? Next time, just please listen to what I'm saying when I say I need a particular kind of needle to draw blood with. It's like, I'm not practicing a deception here. Yeah, it's a horrible they use the giant. I don't mean to make people cringe. I'm sorry. I shouldn't make people cringe, but they used a larger syringe on that, and it slipped off, and I was like, come on. It's like a bloodbath. I'll be a vampire next stream. It might not hurt as much if I was a vampire. Okay, so audio output is coming from a PWM line. And which one is it coming from? I've actually marked it down. P2. IP2. That would be that one on the right. Okay. So we plug into this one here with a test lead. We go down to here. But that's not all. I need power and ground down to this little guy right here. And then we'll figure out what code we're putting in. We're going to put in a very rudimentary program. It's going to be a very simple program. So yellow for power. We're not old school. We don't use red for power. Actually, the color scheme that I typically do is 12 volts is on yellow, but we won't do that. And then, do I have a black wire? I do not have a black wire. There's not one in here. So we'll use blue because it's dark. That way we mildly communicate to ourselves what the different wires do. Not really. I mean, color coding is nice. Sometimes you can't do it. So positive power is 3 volts is the third pin down. So 1, 2, 3 right here. Right? Oh, does this one have solder on it? I think there's a little remnants of solder on this one, so it doesn't plug in as easily. Let's just check to see that that's 3 volts. Oh, output is off. Oh god, I forgot that I changed the scale of that axis. I thought that had like 12, full-on fucking 12 volts on it. Whew, that's... Fool me once. Shame on, you fool. You shame me. You shame me the fool again. You want that you look like that you want to look like you can do anything? I saw a documentary on that kid, the You Want kid, or whatever You Want look like kid, and apparently he was quoting Hercules, the Danny DeVito speech in Hercules. You want to be able to do anything, or something like that. I don't know the speech personally, but apparently the kid was just quoting that speech. And there's a whole like little documentary about how it was released and everything, and became a huge meme. Let's see here. So, our microcontroller has power. It has the ability to output on P2. Let's make it do thing. Want that look like? You want that you can, you want you do anything. New program. New program. I need to go through my Arduino. I think I just need to install the latest version of Arduino and just move over to it. Because we're running on 1.8. I don't know how many versions above that we are. All right, so file save as. We're going to call this one. Well, we need to put it in the right folder. So, network, FreeNAS, project, stream. And then we go down to synth. And then we are X4046 V2 is where I've been saving everything because I'm dumb. It had a 40 in it, and so I thought, so this would be VCO test, or 2040 VCO test. So this is our VCO tester. So let's go ahead and just put like a header on this just so that we give everybody credit. Once I get control of the mouse back, there we go. RP 2040 VCO test program, please ignore. And then I'm going to give credit where due, all the way back up to the top here. And we're just going to give all of these links in. And I guess we'll just hit the ground running, yeah? Test build up of Stuffington. Okay, so the whole purpose of this is something that I do often in microcontrollers. With microcontrollers, you have this wonderful hardware layer that you get to play around in. And the cool part about this is that what we can do is we can throw in, hey, RYG, thank you for subbing. Came here for nerdy stuff, stayed for the beautiful hair. Hair's so healthy, it shines. Hair's so greasy, it shines. I have way too much hair. I really do need to get a haircut. It's getting bad. It's starting to define who I am by a little bit too much of a margin. And it needs styling. Look at that. What the hell's going on back there? It's because I twirl my hair. This stuff gets all ridiculous. God, it's just been laziness. My local haircut place moved away. So now I don't have a place to go. With great hair comes great responsibility. How's Willow? Just about as hairy as I am. Yeah, she doesn't come downstairs anymore. She tore her ACL. Not, well, a little bit. She stretched her ACL, and there's a little bit of fraying on it, and on her passenger rear leg. And she's been hobbling and limping around for a little bit now. It's been a couple weeks of that, and she should be getting better, and I think she is. It's just very hard to tell. Willow's upstairs. She's not coming down the stairs anymore. Yeah, I don't know. I don't see her as much anymore. I wish she would visit me more, but her leg hurts, so she needs to be at the front door where she's not stressing herself out and she's sleeping. So she's been very cute, and I posted plenty of pictures in the Discord. Yeah, I know. We might have to get a surgery where they put a metal cable around the leg, and that holds it together instead of that tendon. But I don't want to have to get an expensive surgery. But my puppy is hobbling all over the place. It's very pathetic. Once she gets the leg warmed up a little bit, she'll use it, but we have to be keeping her off of it as much as possible, as much as humanly possible. But then she gets like cabin fever and starts getting the wiggles, and we can't do anything about it. But what we can do is limit her stair travel, and so she's not allowed to come down here right now, which is very sad. I wish I had the puppy here because I got the puppy bed under my other desk, and it's nice to have her sleeping there while I'm working and stuff. But one day we'll get back to that one day. Anyway, so the cool part about what we're doing with this program is we can introduce small elements of the code and vet out if it works. So let's do some of that. first things first, I want to test this audio output. The audio output scheme on this is the following. Where did my picture go? Oh, it's in MS Paint. The audio output was going to be a PWM, a super audio, a super audible. How do you get above audio frequencies that you can hear? I don't know what the term is for that. We get a PWM signal going in here, and it hits this filter structure, and that filter structure is resistor, capacitor, resistor, capacitor. And I don't remember the math. I don't remember the math that's involved with that, the circuit analysis, the loops that are involved. It's basically bleeding off high frequencies through the caps. I'm not exactly sure what's going on. Listen, I would know this, but I don't remember the math. But so what's going on here is this PWM frequency is being hit by this low-pass filter, and it becomes audible frequencies. And so those audible frequencies go into an op amp where they are then amplified into plus minus. Well, this one is positive. Or no, what's going on here? I guess it is being turned into 5-volt audio, plus minus 5-volt audio. So if you plug your headphones into this, they'll explode. But we've decided instead to use a Salin key low-pass filter. And if we look that up, we can figure out what some of the math is there. Salin key low-pass filter. The problem is Salin key topology. Like, I don't want to do all this math. A VCS filters voltage amplifier with practically infinite input impedance and zero output. To implement a two-pole low-pass, high-pass, bandpass, stop-pass, pass. It's basically an equation. V in and V out equation, right? This is, I blame, curse you, Fourier. Op amps are crazy math engines, and basically, yeah, it's all Fourier transfers and feedbacks. Yeah, square wave being a sum. Yeah, you can post a link, RYG. I trust you. I trust you. Combining equation 2 and 3, blah, 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 blah. Anyway, the point is Z3, Z4 over Z1, Z2 plus Z3 times the sum of Z1 plus Z2 plus Z3 plus Z2 times Z4. Z, 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 Z. A lot of Z's. A lot of resistances in here. Anyway, so V out over V in, all that business. What it's really supposed to be doing is turning a high frequency PWM into audible frequencies. Oh, is it completely unrelated to what we're talking about? System of a down but piano. That's not relevant at all. No, you can't post links like that. Silly. Post that in the music section of the Discord. Let's see. So yeah, we don't have to worry about a lot of this stuff. Basically what we've done is we've copied Mutable Instruments Salin key bandpass filter, low pass filter. The problem is I don't know if Mutable Instruments is doing the same thing that we are. I don't know if they're doing the same thing that the RP2040 is. So what we need to do is we need to set that PWM to something that we know and see if we get audio frequencies out of it. And the things that we know are what's provided for in Hagiwo's code. So we need to run one of the waves in order to make something happen. I think what we can do is just take, how can we do that actually, to be honest? I think we need to look at how this code works. We need to step through the code and pull out the things that will actually make our PWM frequency output. Oh boy, this is a lot. Suddenly this became a lot because reading through this code is a chore. So our code, the first thing we're going to need is hardware pwm.h, which I don't know how that works, and we're going to have to look it up. Where's my code? So this is our blank code. So we're going to need hardware pwm.h. So I'm going to look up RP2040 PWM or hardware pwm.h. RP2040 PWM library. I don't think this is the right one. I don't know what the we'll have to figure it out. Hold on. This means we need to actually go into the folders for the Arduino. So what I need to do is I need to go to app data. For such rudimentary programming software, such simplistic programming software, I find myself having to go into these folders far too often. So there should be Arduino 15, but we're in roaming, so we want to go to local. And there's Arduino 15. Cache, logs, packages, staging. What are we looking at? Package 2040, index.json. We're looking at, I think it's going to be in the packages. RP2040. Those are tools. What's that? Python 3, blah, 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 GCC. Okay. Hardware 2040, 372. Do we have like PWM? Well, it was in hardware. It said hardware PWM, but I don't think that's this. Core API, docs include libraries. Arduino OTA, joystick, mouse, PDM. There's a lot of files when it comes to using these microcontrollers. PWM, I'm not, PWM audio. Huh. Sound key will do the same job as the passive version, but the cutoff frequency you have using the values on your schematic is not the same as the passive version. So you may need to change some values to get the exact same results as the passive version. I don't need the exact same results. I would hope that Mutables is using similar, you know, techniques. Although, yeah, I mean, maybe we'll have to do a couple bandpass calculations here in order to get the right values. So, okay, so we'll do the same thing, but what is all this about? This is like an audio example. I just want to look this up. Really? 11 kilohertz versus 44. That's a significant number of kilohertz. But it's not, is it not, it's not so much about the cutoff. That's not the point of it. It's the cutoff. It's the filtering into audio frequencies. Raw headerless mono 16 dB, 44.1 sample using the PWM audio library on GPIO 1. This is different. This is a different thing entirely. Interesting. Okay. That's a totally different thing about using PWM to get audio. So what are we looking for? I'm looking for the PWM, and supposedly it's in hardware. Well, I'm in the wrong place to find that, but hardware/pwm.h. We're looking at libraries, so I don't know if we're going to find what we're looking for here, because all we have is PWM audio. Unless there's a hardware folder. No, it's a different location. Different location entirely. So where do we find a hardware folder? Looking at docs. PWM. PWM audio library. Oh, that's a different one. Relatively good quality analog audio can be generated using the RP2040 onboard PWM hardware. It can drive an amplifier for speaker output or be decoupled using a capacitor to drive a headphone level signal. Mono and stereo signals can be generated. All samples are sent to the PWM audio library assigned 16-bit per sample due to blah, 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 blah. Okay, so this is different. This is like direct output of audio. We're not doing direct. We're doing something a little different. So where then would that be? That's not it. Where does the include pull from? Arduino 15, packages, RP2040, and then are we pulling from hardware, in which case there's, all there is RP2040 in there, and then 3.72. I don't know where PWM is. and change the original Hagiwo code and get it to output a constant PWM of your choice? Probably, but I would like to learn how the program works at the same time. So I'm going to be pulling over parts of the program in order to test. But for that, I need to know how the PWM output works in the first place. So I need to look up documentation on this library here, hardware pwm.h. Which, wouldn't that be a library? What am I looking for? I'm looking for the include library. I'm looking for hardware. Would it just be called hardware? Hash. Mouse, PWM servo, wire, whatever. Nope. C, fast LED, blah, blah, blah. So is there an RP2040 section here? Contributed libraries. 8266. Not really. Servo RP2040. Serial Bluetooth, Twitch IRC API master, blah, 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 WebSockets, Wi-Fi timer, LVGL, host. So examples actually is what I'm looking for, which for some reason is in the file menu. And RP2040 should have its own full thing. RP2040. Tone, happy birthday, time, temperature, siren, multi-core, get cycle count, fade, and boot select. So there's not a ton of examples in here. What'd you find? Pico SDK. Oh, so that's from the Pico. God, this stuff takes forever to figure out. RP2 Carmen hardware, PWM include hardware.h. Hardware 2? Huh? Pico.h, hardware structs PWM.h. That's hardware structs, though. Ah, but this is the right, yeah. Param assertations, blah, blah, blah. This is some weird code. Okay, so what we have in this code is this block of PWM stuff in the PWM setting. So let's grab this and let's bring it over to our other code, and we'll see what's going on here. So bring this into here. So in setup, and then we need our pin as well, and that would be D8. We'll probably need a couple settings in there too, because all this stuff is, yeah. But okay, so GPIO set function, slice number, PWM clear IRQ, set IRQ, set exclusive handler, set enabled, clock division, wrap, and enabled. Jeez, that's a lot. That's a lot. So let's take a look at what this stuff says it is. PWM config. Check slice number parameter. Man, it would be nice if they actually like explained any of this. I guess there's a little bit of explanation. Check slice number. I guess that references that it's like I don't know, it's counting slices of time. Determine the PWM slice that's attached to the specific... Oh, no, never mind. This is different. PWM GPIO to slice number. No. Don't bring me into that. GPIO to channel. Determine the PWM channel that's attached to the specific GPIO. PWM config set phase correct. Set the phase correction to a PWM configuration. Man, this is complicated. Phase correct, clock div. What does function do? That's the wrong window. Cool, it's not anywhere on this page. It's 80 in 80 places on this page, and it's not telling me any of them. All right, I'll do the whole one. Now we're on the page. I don't know if this is the right documentation. Unless this GPIO set function is not related to PWM, because we're GPIO function PWM, set GP2 to function PWM. So I guess that's somewhere else. Where would that be? Well, let's just Google the command. So this is in GPIO. Select GPIO function. Oops, hold on. Set function, functions. Whoa. Okay. It just loaded a whole bunch of stuff that I didn't need and put me in the middle of the page. What the? This thing's stupid. There we go. Which GPIO function select to use from list GPIO function? GPIO function. This documentation sucks. At least it exists. GPIOs. Please refer to the data sheet for more information on GPIO function select. Man, come on. You're giving me the runaround, this documentation. What are you linking me? Hardware APIs. IRQ callback. This always, it almost seems like it brings me to a random part of the page. Let's see if it gets it right now. Set input hysteresis, set output, set in over. That's I don't know where the location on the page that's taking me is not relevant. But okay, so we have a bunch of GPIO functions to set up here on the RP2040. I guess it just does things a little differently with these function parameters when you use a special feature. PWM GPIO to slice number. So that's a PWM specific one. Let's look up that one. Well, GPIO set functions, that's going to be audio out, because now we've confirmed that that is in fact defining pin 2. PWM GPIO to slice number, what is that number to? Determine the PWM slice that is attached to the specified GPIO. So if that's the GPIO, then that's going to be audio out. Okay. Clear IRQ. PWM clear IRQ. So that's going to clear the interrupt request, right? Remember when you had to set interrupts on like audio cards for computers? But so much trouble getting joysticks working when the interrupts weren't right. Clear single channel interrupt. Okay, so I guess that's just initializing. Set IRQ enabled, slice number true. So we're using that slice number as the definition. Unit slice number bool enabled. Enable PWM instance interrupt. Used to enable single PWM. And I guess the interrupt is important for very quickly affecting the PWM output, making it change so that it becomes audio. IRQ set exclusive handler. So that's, oh, I see. So that's what's initiating the wrap function. So I guess IRQ handler T handler PWM IRQ wrap on PWM wrap. What is going on there? There's a unit number on that though. Oh, that's set exclusive handler. That's not the right one. No, that is the right one. Select an exclusive interrupt handler for an interrupt on the executing core. Use this method to set a handler for single IRQ source interrupts, or when your code uses, when your code use case or performance requirements dictate that there should be no other handlers for the interrupt. This method will assert if there is already any sort of interrupt handler installed for the specified IRQ number. Jesus. Interrupt number handler, so that's the number, and then the handler to set, see IRQ handler T. Method is to add a handler on the IRQ number, blah, blah, blah. Headers added by this method with all called sequence from highest order priority to lowest. The IRQ set exclusive handler method should be used instead if you know there will be or should be. This method will assert if there's an exclusive interrupt handler. Jeez, I can't keep all this stuff straight. So the handler is just a function. So on PWM wrap is what happens when PWM IRQ wrap. Oh no, that's the handler? IRQ handler T, interrupt handler function type. All interrupt handlers should be of this type and follow the normal ARM IABI register saving conventions. I suppose there's probably a list of them somewhere. Calling IRQ set exclusive handler at runtime to install single handler for the interrupt to the current core. Defining the interrupt handler explicitly in your application by defining a void ISR DMA 0 will make that function the handler of the DMA IRQ 0 on core 0, and you will not. Okay, so this is almost directly the example, except it just has a different interrupt, which is on PWM IRQ wrap runs when the handler on PWM wrap is executed. Nope. Okay. Oh wait, I haven't moved it into this program yet. Hold on. So we have actually a program that is specifically designed to run when the PWM wraps around, when the counter for the PWM wraps around. This is a design by Hagiwo, who's a YouTuber that makes cheap modular instrument stuff, and then we interpret it through the lens of mutable instrument circuits in order to make everything function with op amps, and then I built a PCB for it. So, okay, when that is triggered, it will run right here. Nope, not that one. Not that one. Handle button, handle LED. On PWM wrap happens when the interrupt of this thing, IRQ select exclusive handler, PWM IRQ wrap, it will then run this program. And that program is going down here below the loop. And that is on wrap. We clear the IRQ for the slice number is just, I guess, our identifier of which PWM it is. And then we clear it. F is equal to F plus oscillator frequency. Why are we adding it to F? What's that going on? If F is greater than 255, F is equal to 0. K is equal to an integer value of F. And then we set channel level of the slice number. So that would be our channel 2 PWM. PWM channel A, what is that one? Set channel level I'm going to look at. And then mod 2 wavetable of K plus 500. What is that number doing there? Because we already multiply everything by 511. Yeah, mutables are really good. What I was able to do is just take circuit elements of the mutable instrument circuits and apply them to the Hagiwo circuit, because the Hagiwo circuit is utilizing the RP2040, but it does something like, uses this low pass filter, whereas mutables uses a Sallen-Key low pass. That's not the Sallen-Key low pass filter. Uses a Sallen-Key low pass filter. This thing up here that I barely understand, but it's, I don't know, maybe it's a little cleaner and tunable. And I also love the -10 voltage reference on the inputs, on the analog inputs, using that -10 voltage reference to move it from -0, 0, all the way down to -10, and then applying it to a 1/3 op amp and having 1/3 inverting, and then having it come out as 3.3 volts. Only backwards. It's upside down. So the more volts are coming in, the less volts are in there. But anyway, it's a very, very cool little way of, and especially the MPC 6000 is only limited to 0 to 3.3 volts. So you don't blow up your microcontroller if stuff goes weird. PWM value 0 to 1023. How do you know all this stuff so quickly, Ben Gizmo? Why are you puppeting me? You're going to tell me all the answers and then I won't know anything. The PWM value is 0 to 1023 and the wavetable values are -512 to 511. How? Why? Why is that like that? What is that about? It just shifts the wavetable. Okay. That makes a... So same principle as our -10 source. Mod 2 wavetable. 4 years of watching these beautiful drawings, says Miguel Oz, subbing for 48 months. Holy crap. Miguel Oz, thank you. I appreciate you very much. That is very nice of you. I somewhat understand it, still learning, but goddamn, I could never like build it out in my head. I've done my 10 years of analog slash somewhat digital circuit analysis for the US government. Well, as a contractor, but so I have been sort of steeped in this sort of thing. Yeah, that's what it's all about, man. But listen, designing circuits is a lot like building software. You kind of put together the big functional blocks, and then you figure out what kind of connective tissue it needs, if at all. And that's sort of what we're doing here. We took blocks of circuitry from one thing and applying it to the other. It's very simple, and that's sort of what we're doing with the software too. We're kind of keeping things on a very low level and trying to just sort of plug the square peg into the round hole. And you can do that. You can do that with anything. All the Mutable Instruments designs are free. They're just out there. Okay, so I'm gonna leave more comprehensive commentary on this. So we are also using Pico PWM, right? Pico, what do we even call that? I mean, we're like, this is a modular approach to modular instruments. So modular synthesizer, modular software, modular GPIO set function. And I'll just link that. People keep closing that door up there. GPIO set function from raspberrypi.com. Let me leave a blank line below it. Yeah, I used the test to take the test. Anyway, all right. Audio out D8, which is actually P2. That is our audio out. So now audio out goes in here. I am absolutely appalled at numbers. If I see numbers in code, I have to attack them. And so that's what we're doing. We're pulling the numbers out of the code. We're putting it all up top in a big old settings file up top. And that will allow us to sleep at night. Because when you have base numbers just sitting down in your code, that means that you have to jump down into that code and figure out where things are getting calculated and stuff in order to affect any change on it. It's especially anathema when it comes to pin numbers. With pin numbers, it is especially just insulting to not have a big block with all of the different pin numbers in it at the top of your code. I might as well just take all of them with me. So I'm going to take all of these pins with me. And then the weird thing is that ours invert. I don't think a Hagiwo's invert. Let's look at Hagiwo's circuit really quickly. I'm already getting a headache. I need to drink more water while I'm streaming. I need agua. All right, let's see this right here. So Hagiwo's circuits, I mean, we're really coming in here hot. He puts a capacitor, he puts a 0.1 off on this. I don't do that. I guess that gives you a little bit of smoothing, but on a time scale that I don't think is really tenable. This thing is screaming away, building all of your PWMs and stuff. So I think, I don't know, it might be necessary to put that in. I probably should have put a dummy capacitor on the schematic, but I didn't do that. So what's going on with this stuff? These are the inputs. This is how Hagiwo does his inputs. And he's got Zener diodes limiting the current. So BAT43 is, I'm trying to see how this thing works. BAT43, oops, no slash. Look up the data sheet. Small signal Schottky. Schottkys let current through without dropping the voltage. I don't know why we would be using a Schottky here, but apparently this is a Schottky. What's the symbol? They don't show, some data sheets are nice enough to show you the symbol. Peak reverse voltage 30 volts. What's the forward voltage? Surge forward current 4 amps. How does this work? 30 volts does not sound like the right thing, but this is BAT43. Maybe he's getting it from somebody other than Vishay. 100 microamps, 7 picofarads, 5 nanoseconds of time. Leakage current, VR, 25 volts. Most complex thing I've designed and built was a remake of some discontinued junk noise generator. Muffenzief. That sounds awesome. Dial up, and then threw together a neat little transistor white noise, snare, clap, soda can. That sounds awesome. Which can be selling soon, which I'm excited for. That's cool. You're actually making something that you can sell. I don't think I can really sell this because I've pretty much stolen all of the everything in this thing is stolen. So I don't think I can really, maybe as a kit. But yeah, that's cool, man. Well, listen, I love hearing about projects, and I don't mind hearing about projects on stream, but if you want true engagement with your project, definitely check out my Discord, because we have personal project section, which actually is getting a little bit busy. I don't know if we need to like do something about that. If I were super organized, and maybe if I was starting this stream today, like if this was my first stream, I would probably want to use the Discord threads. Then again, are they going to discontinue threads? They'll probably be like, nobody was using them, so we stopped. So if I put all of that project data into the thread system that Discord has, they could probably just like snap a finger and it's all gone. But it would have been a good way to organize my stream projects, and maybe have a forum style thing for the Discord for other people's projects too. But it's anyway, you can share progress and stuff, and you know, we'll ooh and ah. Let's see here. So Schottky diode as like a, what exactly are we doing with these Schottkys? And I feel like they're not Schottkys, but I guess we're doing something like this. So what's going on here? Level shifting 5 to 3. So that's what we're doing. We're doing level shifting from plus minus to 0 to 3.3. But how are we doing that so elegantly? Hagiwo has this cool little analog circuit that I don't trust, where from his box voltage, so that's 3.3 volts, down to ground, and we have a voltage divider. We have a 220 and a 330. So 220 to 330, I just got to use a calculator on that. I should be smarter than this, but I'm not. And you can be too. Don't let anybody disparage you about opening up a stupid calculator to do a dumb little calculation for something that you learned in Circuits 101. It's not, there's nothing wrong with that, and the people who like to lord it over your head have never felt a woman's touch. Or a man's touch. Or maybe it depends on what they're into. That gets complicated, but whatever. The point is, they suck. People should not be gatekeeping this kind of stuff on this level. Using a calculator, there's nothing wrong with it. You just do it. Like, it just gives you the number, and you don't have to worry about whether or not your head math worked out because you were listening to a bird outside. A Eurorack breadboard. That's interesting. Everybody pointed me towards the what is it? The online ones where you can just do it digitally. And I'm like, the whole point of this modular synthesizer is that you can buy these circuit boards, and the policy on the circuit board is do not contact the person who designed the circuit board. Good luck, asshole. And I love that, because that just threw me directly into the deep end. I have a Marbles, I have a Kinks, I have a, what is it? What was that one called? I don't know. They're all wobulators of some flavor, but I'm trying to build up more capability on there. You can see those two that are to the upper right are two analog VCOs. One of them has a filter on it. It's a Bic and Tick, and I snapped the circuit board over my knee and then made a bunch of repairs to it. Yeah, the Ornament and Crime uses actually my only two Teensy 3.2s are visible on this display right now. The only two Teensy 3.2s that I have. One of them is in Ornaments and Crimes. Crimes and Ornaments, whatever. Julian always corrects me on that, and I always say the wrong thing, but Ornamental Crimes is over there. That has one Teensy 3.2 that I thought was broken. And the other one that I have is over on the force feedback steering wheel, and you can see it in the upper right area, that little white circuit board. It's sitting right there taunting us. If I need to build another Ornaments and Crimes, I can use that one and then upgrade the wheel to a Teensy 4, but currently the community is scrambling to get a Teensy 4 working with Ornaments and Crimes and Ornamentation or whatever. They took too many shortcuts in the code for that. They used like very specific microcontroller timings, which you're not supposed to do with such a fast microcontroller. With such a fast microcontroller, what you're actually supposed to do is, well, no, it would have been drop-in. This is what I'm getting at. Oh, I see. They made their own. That's actually a drop-in. Okay. It has their own code on it. But like, you're supposed to use generic microcontroller things so that you can move your code from processor to processor. And if they had done that with Ornaments and Crimes, this wouldn't be an issue. You could just buy a pin-compatible Teensy 4 and slap it in there and just go, good luck, sport, have fun out there. But, you know, because they use these very specific timing registers and stuff, they can't swap chips over. You don't do this for the exact reason of what happened to Ornaments and Crimes. There was a supply issue, given that everybody was sick and dying. There was a supply issue, and so a different microcontroller could do the same task, but it didn't have the same registers. So that was the whole issue with Ornamentation Crime thingies. 220, 330, oops, 330, were those K? I think they were K. K. And then we've got 5 volts going into there. That'll bring it down to 3. But then -5 will also become -3, won't it? Oh yeah, circles and squares, yeah. 110, 100 kilo ohm on top of another resistor, and it worked really well. Huh. Yeah, when you start doing the exotic stuff, but there's a whole world of more powerful microcontrollers out there, Mako. Like, you can get stuff that's like a fucking entire computer server on a chip. It's like, so that capability you can get there. You know, you may have to get into exotic microcontrollers, but you can stay in the generic stuff. What's up, Madam? So I'm trying to figure out what these Schmidt triggers are doing. I mean, like, oops, this is clear enough. Right, you're just using the Schmidt trigger as what's going on. Like, when it gets to the voltage, it'll bleed it out. Diode input protection. I mean, that's what most of these, all the good synthesizers have diode input protection, but this is a little different. Yeah, okay, this is a slightly different thing we're doing here. So we got 5 volts in ground, D1 and D2, and then we have So input voltage, let's go to the explanation. How do circuit work? Let's look at different case, see how diode protect. If input voltage higher than supply voltage, 5-volt pin is more negative. What the fuck? Wait, what? Okay, hold on. We're dealing with, yeah, voltage clamping. Yeah, I just want to get a more succinct explanation here. God, that fucking giant bruise from getting blood drawn. All right. Input voltage is higher than supply voltage. The 5-volt pin is more negative than the input voltage. So that's essentially what we're doing. We got 3 volts, and if our input is above 3 volts, the 5 volts becomes more negative, and because we have a Schottky diode there, it's very easily triggered, and so current flows out. So it limits the maximum voltage. I see now. So if the input is below 0, which is, I guess, the system that we're using too, because the leads have been accidentally swapped, oh, that's a bad one, the ground pin is more positive than the output voltage, and so we get a flow into there, and that negates the negative. I don't like that. It's what Hagiwo is doing here, and then he smooths it out with a 0.1 off. So we are voltage dividing this from 5 volts to 3, and then we are taking any negative or overly positive voltages and we are throwing them out the door and limiting this thing. I mean, I knew that was what it was doing. I just wanted a little bit more of a deeper explanation into exactly what's going on. Yeah, they really fucked me up. Like, they always do, too. They're like, oh, this will be fine. I know what I'm doing. And it's like, sucks. I have no choice but to do it, too. Maybe I can give blood or something. Yeet the negativity. Yeah, exactly. So we're yeeting it out to ground. See, I don't like this. I guess you can probably trust it, but I don't like it. It also means that the negative voltages are not used. So what I've done is I've instead put in a mutables instrument circuit that takes the positive and negative 5-volt signal, negative 5 to positive 5-volt signal, and it applies it to a negative 10-volt signal. And what that does is it shifts it negative 10 volts down. So now 5 volts becomes 0, and negative 5 volts becomes negative 10. And when you invert that through an inverting amplifier, it becomes a positive voltage. But because this is an amplifier, it is also a damplifier. So you can put in 33 to your 100K, and you can cut that in thirds. And so a third of the voltage of 10 volts, 3.3. So you get 0 to 3.3. And then just in case, as a good measure, in order to keep Mechatronics Tier 1 for 66 months, damn, these are big numbers. RYG at a 4-month, which is perfectly honorable, but in the face of Miguel Oz, who was 48, and then Mechatronics with 66, no negativity allowed in this circuit. Oh, it's very negative. A damplifier, yeah. I made it up on the spot. Somebody's probably already said it before. But because this op-amp is limited to 3.3 volts, this will not go above 3.3. That gives us a nice little bit of separation here between our scary blow up your microcontroller voltage and our nice cozy 3.3 volts. And then we, of course, put the 470p in there because at the higher frequencies, this amplifier goes fucking psycho. So you want to damp it a little bit, and that's what that does. Those higher frequencies will be let through, and then that will damp it. You're using a real-life meat space map function? Huh? Okay, so yeah, anyway, that's how the mutable instrument circuit works, and it works nicely, and I like it, so I'm going to use it. Okay. So we figured out how that part of that circuit works. Now, anyway, I'm back over here looking at PWM functions. We just got a little distracted by that. Just a little distracted, but it's Friday. We can get distracted. This code rewrite is becoming a little bit more comprehensive. But we did confirm that nothing is inverting on Hagiwo. But ours are. Ours are, in fact, inverting. So we're going to have to invert the way that these inputs come in. I don't know precisely how we'll do that, but we'll figure it out. Maybe we can 1024 minus something. So PWM.H is what's going to allow us to have control of the PWM register that allows us to get into those PWM waves as they're happening and have things that trigger on events and have stuff that can chop up that PWM and turn it into something that'll turn into an audio wave through that Sallen-Key filter. I think the purpose of the Sallen-Key filter is to give it a little bit of persistence, and that way the PWM affects your wave. It basically, I would think, tamps down the PWM and turns it into a wave in some way, shape, or form. That's my theory. I don't know exactly. I mean, Sallen-Key low pass filter. Let's do a little research here. But that's going to talk about so much weird stuff. Maybe maybe a site that says basic electronic tutorials will help. Get out of here. Excuse me. So magnification factor, the Q factor, over time. Sallen-Key filter topology is used as a building block to implement higher order active filters. I'm already lost. The Sallen-Key filter is designed. Sorry. The Sallen-Key filter design is a second order active filter topology which we can use as the basic building blocks for implementing higher order filter circuits, such as low pass filter, high pass filter, and band pass filter circuits. As we have seen in this filter section, electronic filters, I need to read this faster, either passive or active user circuits with signals amplitudes required over a limited range of frequencies. The advantage of using Sallen-Key filters designs is that they are simple to implement and understand. No, they're not! The Sallen-Key topology is an active filter design based around a single non-inverting, operational amplifier and 2 resistors, thus creating a voltage-controlled two resistors creating a voltage-controlled voltage source, VCVS design, voltage source design with filter characteristics of, high input impedance, low output impedance, and good stability, and as such, there's so many commas in the sentence, I'm lost. Allows individual Sallen-Key filter sections to be cascaded together to produce much higher order filters. I don't think we're doing anything like that. Let's remind ourselves of a voltage divider. You put 2 resistors in, and that bleeds some of the current out to ground, and so your voltage is divided. If they're the same value, it's half. God damn it, so many commas. MS-20, I have no idea. I don't know what MS-20 is. Listen, my involvement in modular synthesizers is that my friend has been after me for 25 years in order to build one, right? After me for all that time, and I didn't learn a goddamn thing. And then he said, hey, you could just buy the circuit boards for these things. And that's where I got started. So my whole experience, especially in doing analog, is just there's not a lot of it. I don't know all the lore. I don't know the lore behind every builder of modular synthesizer stuff. And I ran into a few things. Like I bought power supply modules, and Julian took one look at them and he said, never buy from this guy again. I'm like, why? Like, oh, he's an anti-Semite, insane, like awful person that posted a whole like diatribe on their website. And I'm like, what the fuck? Like, so I'm not buying those anymore. You know, there's lore behind all these people. It's like, oh, that person, they make 1 synthesizer a month. It's like, what the fuck? Like, I don't know anything about, I don't know what MS-20 is. It's a synth that has a wicked filter on it. Okay, well, I don't know nothing about nothing. I know a little bit about this stuff. Very little. Very, very little. Which is why we're reading about voltage dividers right now. So yeah, voltage divider, R2 over R1 plus R2, right? Yeah, why? I guess Behringer is another one to avoid too. But Synthrotech, yeah, well, I'm not gonna, I don't think I'm allowed to say mean things about people, but, you know, all the information is there. What would happen if the output of it, okay, whatever, who cares? RC voltage divider, if we change the resistor to a capacitor, how would that affect our previous transfer? Well, it would cut the AC component. We know from tutorials about capacitors that a capacitor behaves like an open circuit once charged when connected to DC, but with AC, it's a different animal. It's the opposite. When a steady-state DC supply is connected to VIN, the capacitor will be fully charged after 5 time constants. So time constants are in there. Everyone I've spoken to about audio equipment says avoid Behringer. Damn, that's crazy. I've heard similar things too, especially through stream. No current flowing the resistor, dropped, developed path, so no output voltage. In other words, capacitors block steady state DC voltages. If we can now change the input supply to an AC sinusoidal voltage, characteristic simple RC circuit completely changed DC per constant. Okay. The problem is I don't want to read this, and then when I skip forward, they're going to base everything off of this knowledge already, and I'll be like, what does this mean? So we're learning about RC filters, and then we learn about op amps, and then they drive through their point by throwing us a Sallen key. So that's a high pass. First and second order. This is like a whole textbook read here. EV magnification factor Q are closely related due to the operation of the Sallen key, mostly in Q greater than 0.5. Will be realized using a non-inverting configuration. The voltage gain AV will be greater than 1 unity, but it must be less than 3, otherwise it's become unstable. The simplest form of the Sallen key filter, designed to use equal capacitor and resistor values, but the C's and R's don't have to be equal. With the operational amplifier configured as a unity gain buffer, as shown, note that resistor RA is no longer connected to ground, but instead provides positive feedback to the amplifier. Hey, you're doing great. You're doing really good. Good job out there. What does ours look like? Looks like a bunch of shit. Let's see. We got 2 resistors, so it's a low pass instead of a high pass. And then we've got a capacitor to ground instead of a resistor to ground. So we are flipping these components in the same way that this is a high pass filter circuit, whereas this is a low pass filter circuit here with these components. So the frequencies that it hits are just a little bit different. But this doesn't relate it to PWM. If you want that explanation, that's on a different page. Yeah, this explanation is concerned with high-pass filtering, I suppose. I don't think I have the equipment to do a Bode plot on that. Okay, so. Started making synths that were not available anymore, and then started making synths that undercut small synth businesses, and we're not subtle about it. Damn, that's fucked up. Well, we found something about my buddy Dave's M303 that I've been repairing, which is a pretty extensive repair because he plugged it in backwards. And there's multiple things that kind of make us throw our nose up at this company, and I'll show you some of them right here because we're talking about unreasonable companies and making stuff that is anti-consumer. Couple little things here. Don't let them fool you. There is a smiley face on the PCB, but acidlab.de makes this M303, M303 is a wonderful little acidic, synthesizer, and these guys made it into a cute little filter / VCO. Cool stuff, right? It is pretty cool. It's a nice little piece of kit. Here's the power plug. How do you plug this thing into power? That's the power plug. Huh? Apparently, this is the power plug. This is all you get. It comes with its own cable, though. This is the cable. This is all you get. The way you're supposed to plug it in is like this. Oh, no, wait, not like that. Hold on, not like that. No. No, you would think you're supposed to plug it in like that. But in fact, you're supposed to plug it in like this. It is a special flat cable, a special IDC cable that is able to plug in offset because you have to plug it in like this. I think. I have to look up the picture again. It might be the other way around. Ridiculous. And if you plug it in wrong, as Dave did, it explodes. And when it explodes, you go, what chips broke? Because chips are typically the things that break. What chips broke? What chip is this? It has been scratched clear. They are trying to keep secrets from us. And only because I had an experienced synth person in chat do we know what this is. We know what this one is, and we know what the other one is, but they are, one of them is a 4-transistor, it's an RF part, a 4-transistor matched pair. This one is one of these ASICs that does the job of one of the synth modules, basically as a chip. But yeah, so these guys are on my shit list for 2 transgressions. One is the offset cable plug, and the second is scratching off the values of components. But we've been slowly, and we haven't come back to this recently, but we've been slowly going through this and figuring out what is what. Because if we know what is what, but they don't know what is what, and we just strut, what the fuck? We can actually figure out what all these components are, and as I go through replacing them, we might be able to get this thing running again. Maybe I can put protection diodes in it or some shit like that. I told Dave, I'm like, Dave, listen, I want to get rid of this plug and put in a shielded plug. But yeah, anyway. They know what is what, but they don't know what is what. They just strut. What the fuck? All right, let's get back to work. That song. Listen, I was in the clubs in the 2000s. That was like a staple. All right. It's a friend and I quote that to each other like throughout all of high school. So we figured out what diodes do. We kind of looked at what Sallen keys does what you want that you can do that you can do anything. Anyway. Yeah, sorry, my brain is like half functional today. We've got a lot of very complicated stuff going on here, and I'm trying to sort of figure out what it's all doing at once. And as we get deeper into the code, it's going to get even more complicated. But once I can figure that out, I can turn it into something simple. Because I like thinking about things simple, because I am a simpleton. I don't like complicated code that has a bunch of repetitive blocks of things in it. And one of the repetitive blocks of things that I've identified that I will fix some other time is all of the equations that are making the different waves are all samey, right? We've got sine 2 times something. You can see the repeating functionality in here. And as you go through, functions are added into that. So I feel like I can make some kind of a, what do you call it again? I can make a function. I can make a function that has a bunch of these elements in it. And as you like do the business of the function, it will cancel out the coefficients that aren't being used. And that way you can have just something that'll help you, do whatever. Speaking of Sallen key, VCO makes a killer filter. I don't have filters. I need to get filters. But again, with the philosophy of this synthesizer, I am going to either buy other people's circuit boards, not DIY kits though. DIY kits, typically, they didn't do that with this one. This is a good DIY kit then. This would be a good DIY kit for somebody else. Because I want to use all my own components. I want to use all of, I don't want, what they do sometimes with these synthesizer kits is they will do all of the surface mount soldering for you. Which, that's cheating because I'm a professional. I have a very high-powered microscope that can do a lot of really cool stuff. And I would be robbing you guys of the pleasure of having a good soldering stream if I did that. But I need to get more filters. I don't want to buy the kit though. Oops, that's the wrong. That's the searching around for something on the floor cam. We used that when I built the little RC car. Okay, so what are due? Let's take a look. Medium grade, not even high grade components. Close this. Close this. VCO. I've heard of them, I think. Oh, started as a makerspace. No, so as much as it pains me, the mutable instrument circuit boards use the smallest size. The more through, I don't know the pronunciation with all of the accent marks, but Amelia, is Emilie? I don't know which one to say, but Gillette, as her career progresses, you can see the move from larger, easily DIY surface mount to the absolute bullshittest tiny size of surface mount components. I found 0603 is a nice place to be. 0805 is nice and easy. 1206 is needlessly large. 0402 sized resistors, aka that stuff you're looking at down there, this stuff, they make you feel the most inadequate. I can get the microscope very close to that stuff, and then everything looks kind of like normal sized electronics, except that you are completely inept. It's ridiculous. Yeah, those are the sneeze and lose it parts. All right, we're very highly distractible today, folks. I'm sorry if you wanted hardcore programming. I guess yesterday's stream was for you. Friday, we kind of loosened the belt a little bit. So I'm trying to learn what all these PWM functions are doing right now. That's what I'm trying to do. We got a little distracted looking at filters and keys and stuff. And we're going to have to, our inputs are reversed. And from our inputs are reversed -5 to 5 volt is 3.3 volt to 0. And I guess the Salin key is not inverting anything. No, listen, it's Friday. That's what Friday is all about. So we do the Salin key bandpass filter, and that turns our PWM into audio frequency. To audio. Non-invert. But then we're throwing it into, well, this is DC kill. So rather AC kill. Although we shouldn't need an AC kill here, unless this is shifting it in some way, but I don't think it is. We're getting a 0 to 3.3 volt signal for audio coming out here, and we're getting a wave. I guess maybe this... That's not AC kill. No, that's DC kill. Oh, I see. So we're taking our 3.3 volt, like this, and then through here, it's becoming positive -2.5. Wait, positive and negative 1.6. And then we put it through 24.9 to 1. And I don't know what all these shenanigans are over here. I looked it up. I found it on a synthesizer forum, what this is doing. I forget what it does. Somebody in chat remembers. What about you, Bing Gizmo? I know you know this. What this filter structure is doing. Met the guys from VCO at KnobCon. None of these words are insane. It's going to KnobCon. I'm gonna go to KnobCon and get some slob. Anyway, I met with the guys from VCO at KnobCon last year. VCO reminds me of Bug Snacks for some reason. Maybe it's Bethany. Yeah, it sounds like it'd be a lot of fun, to be honest. Me and my colleagues had a very heated debate about making SMD kits because they're very against it as much as possible, but we were debating if it could be approachable. Oh, it's totally approachable. Surface mount is easier than through-hole. I'll say that right now, and it's my hottest take. Oh, so it's stable driving a capacitive load. Is that just like a known thing? You put a 1K resistor in there like that, and that's just what it does? Because I read it kind of matter-of-fact like that on the forum. So surface mount electronics. If you stick to SO8 and 0805, you can have an amateur solder surface mount. Surface mount is easy. Through-hole is difficult. It creates sharp things that'll catch your skin and cut you. It's horrible. Surface mount is so nice. You should definitely always work in it. You can also do, if you buy a perforated prototyping board that has square pads, you can actually use that to very easily lay out all kinds of different surface mount stuff. It's easier to clean. Yeah, exactly. It's stronger. In many instances, it's actually much stronger than through-hole. It takes up less space. It's not Radio Shack repairable. That was something that a friend of mine with a mixing console was telling me about. Like the mixing console that he used to use in like on movie sets or TV sets. If something broke on it, he was able to pull the module out and buy another resistor and put that in there. That's not as cut and dry anymore because Radio Shack's gone. But I just think there's so many advantages of big surface mount circuits, and especially in the synth DIY realm. Like you should be able to solder surface mount. You should have a pair of very attractive looking goggles that will allow you to see. Where do they go? What happened to those? Hold on, let me get them. Very, very cool looking. Definitely very cool looking goggles that allow you to take a look at stuff very close up, and you look really cool while using them, to be honest. Yeah, those are, so these are like a necessary thing for surface mount, and they have a little light on them too. So like a headlamp and a jeweler's loop is what I used to use. But like this kind of stuff makes it super easy to actually work on surface mount, because I mean you do kind of have to hunch over a table, which is why my microscope is so nice. I don't have to hunch. I use the monitor. But yeah, this right here, this is like a cheap Amazon thing. Like my mother actually bought the exact same thing without knowing it for cross stitching, so helps massively. And then in order to surface mount solder things, put the pads of your hands on the frickin' table. Don't try to suspend your hand and solder stuff. You will be very unstable. The whole point, it's just like welding. Your body has to be comfortable, and you have to have stability in your setup, and then it's easy to do. It's not hard. I just used those for the first time at my makerspace trying to fix a tiny surface mount project. They're pretty good for what they are. They're a little heavy, but they're cheap plastic. You could buy them just about anywhere. Yeah, those are pretty cool. I didn't expect them to be so cool. 24.9, so it's 100 over 24.9. What does that do? I don't know how to calculate stuff, so I'm just doing 100 over 24.9. So times 4, basically. So 1.6 goes to 6 plus minus 6.4. So that's essentially what's going on there. That is a very big Discord link. It better be relevant. That's pretty cool. Oh, I see. That's a 3D print. Hey, that's pretty cool, actually. Yeah, that seems really neat. That's a good one, although you're still hunchbacked when you use that. I would suggest, if you have the means available to you, that you set up something like I have, where you have a top shelf. And I'll turn off the scope here. You have a top shelf for all your monitors. I'm at a standing height desk, right? So standing height desk so that I can stand up and work if I need to. I have stools from the 1960s in a jar. What? Huh? What are you doing there? Anyway, standing height desks, a shelf on top, and then a monitor with the microscope feed on it via OBS. Not everybody needs this setup, but if you're going to be doing a lot of soldering, you got to watch your back, man. And I mean actually watch your back, as in don't hunch your back, because that'll pay dividends in the future. And if you're getting a computer chair, don't get a racing chair. Get an actual, like, office chair. Ergonomics are super important. Super important. All right, so just a little bit of calculation to give me an idea of where we're coming from here. So our PWM is I don't know the frequencies. That's a lot of frequency calculation. So we need something that is going to be able to output some kind of PWM. So what we do is in our setup, we're going to start setting up our pin 2. And we're only concerned with pin 2 right now. We're not going to put any kind of button functionality or anything like that in there. We want this thing to just output a frequency. And maybe we can have it output 2 frequencies. That'll be something that we'll control in the loop using timings. So our knowledge of microcontrollers is vast. We know all kinds of different programming techniques. We're not going to use any of them. We're going to do the bare minimum, simplest thing we can possibly put together to test one pin so that we can see the hardware functionality of the Sallen-Key filter in regards to the types of PWM that this specific code is going to put out to vet out whether or not this entire thing is possible. And I think it is. I think we actually, the stuff that I've been seeing from Hagiwo is possibly very similar to what Mutable Instruments does. We have Mutable Instruments code. We could look at that, but I don't think we need to. I don't really want to look at that STM stuff. That stuff scares me. So GPIO set function audio out GPIO function PWM. What we're doing is we are setting our audio out pin to the GPIO function PWM. So that tells the RP2040 that, hey, I want to use this specific pin. And the RP2040 goes, cool, I set it all up. And we're like, wait a minute. We need to know what slice number of PWM you've set our specific pin to. So PWM GPIO 2 slice number, and then we give it the pin. We said, hey, we assigned this pin number. And it says, oh, here's your slice number. So we get our slice number variable in here. So we actually need int slice number in one of our variables, which is a weird way to do it, because that could potentially be a fixed value, which would save us a little bit of memory. But let's put int slice number into our code here. This is also going to do the function of actually organizing the variables so that I have them in a logical progression. "25 years of IT work and no exercise resulted in a pinch." Oh, sciatica. Oh no, that's in your neck. That's a different one. A couple of years ago. Now I'm one of those people who goes to the gym every week. Back day, very important. That's listen to other people's experience out there. If we can reach one person and get them to buy a chair that's not a hatefully shitty failed racing chair company that went, oh no, wait, I have to put these into a crash test to tell whether or not people get fucking destroyed by our chair in a crash. Never mind, we're not going to sell these for cars. Let's put some casters on it and sell it to gamers. Dumb. It's the worst fucking thing ever. Those chairs are designed to keep you in a seat with lateral forces. They're not designed to be kind on your back or good for your back or in any way, shape, or form a good office chair. So, yeah. Upright frickin' rows. Yeah, a good bed is a good purchase, too. I think I need to get a new bed. It's too hot. My bed is way too hot. It's a foam mattress, and it's like, I wake up just in a puddle of sweat. Like, what the fuck? I have to do the one leg out thing. So one leg is overheating and the other one is cool, and the blood flowing through it is like a frickin' like power plant diagram with superheated blood and cooled blood flowing through my body. Okay, so we have our variable there for GPIO, or for slice number. Apparently that's just an integer. What is it returning? Can we save memory? I don't even know if I have to save memory. It's just this is just the habits that I'm into for programming, is to try to save all the entry. So, I read the word entry and it just came out of my mouth. uint GPIO. Use the PWM to initialize the config structure, make changes needed using PWM config functions, call the function, set up a PWM. PWM slice number, PWM slice number. Okay, so I guess unsigned integer, huh? Is that a 16? I'm sorry, do what? Wait a minute. Slice number, slice number, slice number. Well, let's look up the specific command then. GPIO2 slice number. Boop. It's going to say it just returns a slice number object. Slice number 0. Find which PWM slice is connected to GPI 0. Oh, I see. That's find out which one. Yeah, this is basically this procedure, isn't it? Set period of 4 cycles, 0 to 3 inclusive. Slice number 3, and that's when it wraps. Oh, see, this is a more comprehensive example. This is actually doing the same stuff we are. If you do end up selling synth stuff, sell them in mason jars. What, huh? That's a weird one. It would actually be kind of cool to build a circuit in a mason jar. You could have multiple levels, and it would look kind of like an underground facility. You know, little lights going off. You could buy some model people from like model train sets and like put them in there. There was actually an artist that did a bunch of collage work, I think, and I had a book of all that work. And one of the little asides at the beginning of it was how this artist liked to synth. Maybe I may have lost the thread. But one of the things that this artist does in all his like radios and stuff is electronics. He'll put little train set people all over them and have them like look like they're doing stuff in the electronics. I thought that was cute. I'm not looking up anything to do with jars on stream. Jesus Christ, you people. You should know that I'm like giving that one a wide berth. I'm not going anywhere fucking near that shit. Nope, you cannot convince me. Like, is it just like some number? I feel bad giving it an entire int, because that's like a 16-bit number. It's not going to be slice number 20 billion. It might be like slice number 4. Air circuits and puts them in baby food and tuna cans. That's pretty cool. Yeah. I'll get a kick out of that once my Friday's done. I gotta get back to uploading videos. I've only got like 5 days of videos ahead of time. So I meant to be months ahead at this point. Okay, let's take a look at what else we're doing here. I think we're basically following the example. So let me go back to that example. I think it's following this example pretty... Oh, damn it. Zooming in is causing this thing to go all over the place. There we go. I think we're doing this. Hardware PWM.h. Set function. Slice number is equal to this. Set wrap. Set channel level. Okay, so maybe... Well, set channel level seems to be what we're doing in order to set the output. So let's take a look at the code. So we're clearing the interrupt request of that slice number. Set IRQ enabled to true. So event and function. So the event is on IRQ wrap, and then on PWM wrap, we execute that function. And enable function. That's weird that we would have to enable it. IRQ set enabled. I guess you could enable and disable it from there. That's just an extra little bit of control. PWM set enabled, slice number true. We could also use PWM set GPIO level, GPIO-X, which looks up the correct slice and channel for a given GPIO. You could actually do multiple IOs with this. Yeah, just enables the interrupt. Okay, so then we set the frequency. We're only doing that during setup, though. I guess maybe the other time we set the frequency is down here. Or no, set the level? Set clock div, slice number 1. System clock over resolution +1 times free. What? Why is it set to 1? Set wrap, slice number. Okay, we'll have to look at that one. We'll change that to a variable as well. Mod 2 wavetable of K plus 511 to shift. So every time that happens, so we're clearing the interrupt. then F is equal to F plus oscillator frequency. If F is greater than 255, F is equal to 0. Why are we doing this? What is that accomplishing? K is the integer version of F. If F is greater than, so 0 to 255, we're looking it up on our mod 2 wavetable, which God knows where the hell that comes from. Because in the setup, we don't have mod 2 wavetable yet. We start off with setting, this is just setting the base frequency. So let's just look that up real quick. Set wrap. Set the current PWM counter wrap value. Does that mean that it wraps on that value, or it wraps? This says it wraps on 3. We're setting it to 1024. So we're going to do a setting. Put that right below the pinouts. And we're going to do define PWM wrap. It's 1024. 2023. Slice number, and then PWM wrap. And then we enable it. I don't need this. We are in the right code, right? Yeah, okay. I have so many windows open, I need to make sure that I'm in the right place. Yeah, output enabled does not garner a comment. Resolution, we'll put PWM resolution, and then set clock div to 1. I mean, I guess I need define PWM C div 1. That seems useless, but it's, I mean, it's just there for clarity's sake. Selecting the sample in the wavetable output. Like where it starts. Hold on. Where's that number 1? Oops. So it's system clock over resolution plus 1 times frequency. Huh. But it's 1024 times, what was the frequency? Yeah, I don't really know. PWM clear, slice number, blah, 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 blah. Enable slice true, IRQ wrap true. Excuse me, IRQ enabled true. Audio out there, slice number there, okay. This would be set function audio out, so set up, set the pin, set pin and get ID for pin. It's not really the ID for the pin, but that's close enough. And then this whole block can get its own setup PWM. Its own big thing, its own big jim jam. And then I get, do I still need to have that pin defined as an output? I might not, but I'll do it anyway. We'll take that whole block and just move it into here. And keep our style notes going. Yeah. Stylish. The equals just help me kind of like scroll through and focus on specific things. Bop, 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 bop. Put my main code here to run repeatedly. Don't mind if I do. So we've set up our PWM. Now we need to figure out what the hell we're going to output to it. Currently, what's going to happen is once that PWM rolls over, we will set up this interrupt. I've seen code where they don't even use a loop. It's just all interrupt driven. But I don't think we're interrupt driven in this one, to be honest, because we have user stuff going on in the background, and we need to calculate out some pretty heady tables in order to run this stuff. So we need a wave table. Where is that even set up? We may not have that. Mod 2 wave table, mod wave table, wave table. There's a lot of stuff. And there's also this mod here. Slice number, oscillate frequency. Where's that coming from? That's from here, so we do actually need that variable. Osc frequency and K. I don't know why that needs to be a variable, but we'll take it. We will take these. We're trying to get one PWM running, and we're just now getting into what's running the code. K is equal to 1. F is equal to 0 for some reason. We already have slice number. We need osc frequency. And then this stuff. ADC frequency pot octaswitch. We don't need that stuff yet. So maybe we take these wave tables and the mod number, whatever that float is supposed to be. And waveform is a selector, so. So those are for the wave tables. And then in our setup, we probably want to build them, which we determined that it's a little different from what was originally. Oh, there's also frequency table. Oh my God. So many tables. There's no explanation as to what frequency table is. Wave table, mod 2 wave table, frequency table. Why are we double modulating? What does that even mean? 256 rate. Strange. Okay. I mean, this stuff, if you guys want the explanation, I don't necessarily understand all of it, but we do have a page that goes into some of it and how these sounds are made. And that is with this person's blog.buchao.com Pico PWM sound. You got to translate it. You got to use the Google Translate function to translate it from Japanese. But apparently using the wavetable, you can, using wavetables or whatever, you can create sound from PWM. Square wave using a PWM and produces a buzzer sound like the tone function of Arduino. It's possible, though, with this method, volume control can be adjusted and the waveform is only square wave. There's several ways to use PWM to produce sounds other than square waves. Generate a square wave with an inaudible high frequency with a fixed value and modulate the duty ratio of the audio signal. Square wave itself has two values, 1 or 0, but by passing the square wave through a low pass filter, you can extract an audio signal used for modulation. So the duty cycle is what we're changing in this thing. That's why we're dealing with interrupts and the high resolution PWM. That's why we have 1024 entries. So we can come in there and change the duty cycle on it, and it'll change the output wave, or it'll produce an output wave. P27 software created a simple synthesizer, multiple channels of square waves, sawtooth waves, and triangle waves, and the noise can be output. Frequency volume can be set. Okay. This code is a little bit different from what Hagiwo is exactly doing, but this whole thing is based on this principle. So what do I need to set up in order to run some of these actual functions? Because every time that interrupt, the wrap interrupt is triggered, we're going to have a change in the frequency, or maybe not every time, but whatever, the change in what's going on. Sorry, I'm trying to open up Windows. I've got 1,000 things open on this computer. Originally, this used this huge frequency table. V octave covers 6 octaves. If it's 1230 or more, the operation becomes unstable. Voct pow. So when the table's set, when the octave's selected rather, I is equal to 0, I is less than 1230, I plus plus, frequency table is equal to F0 times power of 2 of whatever value it brings up. What is that equation though? And that turns it into frequency table. This one's Voct pow. But Voct pow can be calculated. And so, and it's linear. So what that turns into is what I have in my code, which is, I gotta find it. Table set. So I'm gonna take table set. I guess I need it. Whereas this is the VCO only, and I'm looking for the test program, and we're going to take the table maker, make a huge F off table, and in table set, what we do is the business of octave selecting as well as setting up that huge table. Wait, this is the wrong one. Need to go here. Function table set. There it is. Table set. So we put that down in our functions. What else is happening in table set? Wait a sec. Let's look at the original code. I got the original code. I've got my rewrite from yesterday, and then I've got the code that we're working on currently. We're pulling things in for the singular task of setting something to come out of that PWM so that we can observe on the other side some kind of an audio frequency. So table set. Push switch digital read waveform table set. Void table set. Ooh, doggy. So that sets the wavetable based on the mode. And I've done a little bit of work on this thing. I have kind of a rewrite of that. It makes the wavetable based on what setting you've got going into this thing. Oh my God. Why does it do that? Wait a minute, couldn't it just go through and enter the entry instead of going through 0 to 256 on it? I guess then it would have to calculate every single time, but it does calculate every single time, because if it comes through here, then it looks at what your settings are and it sets the table every single time it's called. Well, table set is called initially, and then it's called again and again and again. So this would be octave select instead of table set. So this one's oct cell. And let's get all the way up here to where our setup is. And instead of table set, we still have table set, but we're going to do oct cell. All right, maybe we should keep the underscores, huh? So down here we have, oh, this is the wrong code. Well, whatever. That needs to be edited anyway, because it's not quite the right thing. this is where things kind of fell apart yesterday. I'm trying to replicate what the other program does, so. Where else is table set called? We've got it in, where is that? Table set up there for setting the wavetable. Then we do octave select, which is oct cell. So maybe I should get these into the right order. This is the one with all the debouncer code in it, so this is the wrong one. I'm going to move this off. I'm going to put this way over here so I don't keep getting distracted by it. So then I go to the proper code that we're actually working on, which is this stuff. And I'm looking at, I'm looking at a subscriber. Joda YOLO. Woo! Hey, thanks for subbing. Thank you very much, Joda. This is where it all falls apart. No, we're still going strong. Okay, oct select below table set, just in case. So table set is going in, and it is going. Table set is also push switch is equal to 0 and old push is equal to 1. So once you push the button, if the waveform is greater than 7, waveform is equal to 0. If mode is equal to 0, sets a new table. So it's like every time you push the button to put yourself in a mode, it grabs and creates a wavetable. It creates an entire wavetable every time. So it instead of having like fixed memory values, it'll calculate it each and every time you go into a different mode, which is a little strange. But I guess it works. I don't know. You don't want to have like 10,000 giant tables in your microcontroller. I mean, that would be the way to, like, I don't know. Maybe you could do that. Have it like calculate all of its big tables at the beginning, and then it will have 14 1024 memory and 1024 entry tables that it would create. I mean, it's not unheard of. When you get into like RGBW stuff, you're creating a lot of data like that. So I don't know. I feel like the microcontroller could handle it. On startup, you have it just do a ton of calculations. I don't know. Maybe things change. Things change. But this is when you push the switch, it does the thing. So yeah, for now, what we're going to be doing is having it do just its own singular table setting. So we'll set it up as a sine wave. But right now, we're going to set it up initially. Sets wavetable based on mode. Float, frequency table. Yeah, okay. So we're setting the wave table, not the frequency table. Okay. So table set. Void table set. Sets wavetable based on mode and mode. It's mode and like the waveform button, right? So we go over to table set. Where'd it start? There it is. So mode and waveform. Okay, so based on mode and waveform. But then I got to reorganize this because I think there's a better way to go about it. I think instead of it setting these wavetables in the way that it does, I can break these out into like a common equation and have it either use or discard pieces of the equation, right? If we split it out, we can null out the parts of the you know, like between the multiplies on these things. We can null out the number. We can multiply it by, have it be a multiply by 1, and then it'll cancel out the thing. So this is an RP2040. We're using code that was developed by Hagiwo, who's following, Hagiwo is a YouTuber that does cheap modular instrument stuff, and it was based on a tutorial concept by making a Pico sound with a Raspberry Pi Pico, and that was by Buchao. These are in Japanese, they're translated over, and the code is mad. So, Esteboven, hello from Sweden, hello from America, from Pennsylvania. We don't, I mean, the whole middle of the state is Pennsylvania, but I don't think anybody talks in a southern accent. I hope not, anyway. Hello from Germany, then, yes. Actually, Germans are my second highest viewership. Haha. Germans probably don't appreciate some of the weird stuff that I do around here, but I also do very orderly stuff, which possibly could get me some street cred with them. Hallöchen. Svenska? Talk? What are we doing? The only thing I remember is back in my Volvo 164 days, the website that I would log into to get information about the Volvo 164s had in English, please, and the next step for it, pa svenska talk? And I was like, ah, yes, I am so Swedish. Like, hello from my bathroom. Yeah, that's more common than you would think. I don't know. Listen, how many bathrooms do you guys think I'm in? We've got 50 people here. I could be in 30 bathrooms. It's a little weird. Hi, yes, it's me. I'm in 30 bathrooms simultaneously. Look at me go. In Europe, we all understand each other. My favorite was like Rabaz and some of his ilk were teaching me I think it's Swedish. It might be a different. I say Scandinavian so that I can blanket the whole area. The way to confirm and say yes to something is you go. That's it. That's it. You just breathe out just a little. To exaggerate it, it would be. But yeah, you're just going. It's the most introverted I agree that I've ever run into. Octave select int I is equal to 0 to 1230 I++. 1230 is a number. Did you guys know that? 1230 is a number that we haven't run into yet. Frequency table of I is equal to frequency 0 times the power of it's basically 6.0 times the number 0 to 1230 over the overall range squared times the frequency 0. Northern Sweden, well, that's where saying yes or no can freeze your frickin' face off. So you just go, that's it. What are we doing here? So we need a couple variables in there, and I think I've already done this in my code. So let's just grab my code for octave select, even though it is not in the right place. Oh no, I didn't do a damn thing. Okay, never mind. I didn't do anything, I was confused. So what is 6 and 1230 are the octave numbers and the resolution, right? So define num octs 6 doc oct, and then define oct res. What is this, like 1030? What was that number? 1230. Gets unstable with more. Okay. Num oct octres. Num oct. Num cot. Oct. Upoct. Numbers are illegal. It is illegal to have numbers in your code. Illegal. What is this equation? Number of octs is frequency table of I plus the octave res. For I is equal to 0 to 2. Oh, so that's the second half of that giant table. So that would be freak table size. I don't like putting this in, but I guess I will. Freak size is equal to 2048. Freak size. I guess those are just 256s. So we can take that as freak size. The size of your freak! My corgi is going nuts at the door. Something is happening. So for instance, I is equal to 0 to the frequency size. So that's 0 to 2048 minus the resolution. So what that's doing is it's filling the second half of the table with a frequency table of I plus, what the heck? It's just, I don't know, it's like adding a number. Weird. Okay, well, whatever. It's doing what it was doing before. I just have taken the numbers away. So that's our octave select. And now that we've done that, and we've got our PWM on wrap creating the new frequency there, my head hurts. my head is killing me. Actually, let's not do the equals on these. I'll do just like that, and that way the main headers I can do. Like that. And here I'll just do setup PWM in caps. That's a little better. They're like sub-chapters. Loop! Okay, so far we have set up what happens when the PWM wraps around. We haven't really gone through this, but what we have is our initial setup of PWM. We have the ability to make the initial table, the wave table, and the octave selection stuff. I guess that scales the rest of the table in order to have the appropriate values in the frequency table. So select octave. Sets up freak table at octave scale or something like that. I don't know exactly. On PWM wrap, when PWM finishes, resets freak. A snowstorm swung by yesterday, broke off a third of my ash tree, and then left. Now it's warm and most of the sun's gone. Sorry, most of the snow's gone. Thanks, nature. That was the other day here in PA. We had heavy super winds, and I take Willow on a walk in the sun, and then we are snowed on for the entirety of the walk. We had snow pouring on us the entire time. I got a picture where I look miserable and I have snow in my hair. And then as soon as we got back inside, wet dog, wet human, with snow everywhere, the sun came out and it all melted and it was gone. It didn't actually ever stick. It was just a heavy snowstorm for about 10 minutes. It was really, really strange. Meanwhile, on the weather forecast, they're going, it's going to be 75 degrees. Wow, how nice. Oh, I'm going to put on sandals. It's so great. This is perfect. Everything that we're reporting should be happening, and it's very nice. And it's like, I'm like, dude, it's March. It shouldn't be. I know we get kind of lousy March weather, but like, it shouldn't be this warm. It should not be this warm and this volatile. Yeah, here's functions. I guess we have to organize this code. I wanted this to be much more simplistic, but in order to get this hardware working in the way that it should, it needs all of this structure around it. Test freak. That's it. I'm just going to run test freak, and that will, what'll that do? Or do I not run, actually, wait, we need to run it in the way that it's supposed to be run. And we will just set the mode and stuff. Well, we won't set a mode and stuff. We'll just put it at the base of this whatever it is, the base of the function, right? So let's make a saw wave or a sine. Let's make a sine wave. So for that, we're taking this case out of table set. So table set is just going to be this function. Got our main oak tree decimated this winter. Happy it broke pretty evenly. I got some good woodworking wood out of that, maybe. So we've got just a base equation where we manipulate the wavetable. And then this I'm eventually going to turn into a function. And I'll have it so that the default values will cancel out the things that aren't used. The ash is toast, but it'll stand long enough to decide what to do. Arborist was immediately available. Man, you guys got oak and ash and all these good woods. You can make some cool stuff with that. If you want to get into woodworking, if you want to listen to folk guitar for the rest of your life, in the background of you sitting there with a plane going, yeah, yeah. And then you got to look like me, but be covered in sawdust. And then you'll have to develop a New England accent. So you're like, oh, yes, we're working on the wood today. Ah, yes. I say ah, yes a lot, too. That's the law. I didn't make the law. I just follow it. Wavetable of I is equal to this. And we're running table set at the very beginning of the program. So our wavetable is going to be fixed. We're not going to have all the funky little things that'll change that wavetable. It just seems silly to me that wavetable is a variable. You could have, I mean, this thing, if you're struggling for this thing to function properly, which I don't think is the case, you could calculate all these wavetables. You could have wavetable saw, wavetable FM1, wavetable FM2, because nothing is changing in these numbers, right? From when we assign this. So all we're doing is running this loop and replacing an entire table, which I guess that's one way to break it down, and that's fine. If you really, really want your microcontroller to be screaming fast, you could probably fit all of these tables into the micro very easily. But anyway, we're creating the wavetable based on what mode and what waveform is selected. And in this case, I'm going mode 0 is wavefold. And we're doing a sine wave. And we're not listening to any of our external inputs or anything like that. So in the loop, I'm doing nothing. I'm actually doing nothing. Because when on wrap, the interrupt gets cleared, F is equal to oscillator frequency, F plus osc freak. What is osc freak, you freaking osc? Float, osc freak is equal to 0 in this case. Well, that's just going to be F plus 0, but we already have osc freak in here. But what influences osc freak? That's on wrap. Where are we? Here we go. Frequency calculation. So mode select frequency calculation. Ah, okay, so that applies voltage per oct. So when we change things with our knobs, it's going to get affected by osc freak. So we can keep that at 0. We're just going to assume that it's fixed for now. Frequency table, ADC plus frequency pot. Freak table. Okay, so that's created. Right, that's created when we do table. When we do table set. What is this going? Oh, that's octave select. Oh, octave select is octavizing the thing. Frequency table is created by octave set, and that's it. Okay. Based on what? Based on big boy table, which we turned into an equation. We turned that into an equation because it's linear. I guess if you wanted to have logarithmic frequency select, then you would change that table around. But for us, we could just put in yeah, we could just put in f0 times power and then the number and divided by et cetera, et cetera, et cetera. So, okay, is this looking like this might actually be some code here. We set up our wavetable of I initially, and then when we wrap around, we come down here, f equals f plus 0, so it's still just 0. If f is greater than 255, it doesn't do that. Int k is equal to an integer of f, so that's just 0. PWM set channel level, slice number, that's our pinout. PWM channel A, I don't know what that's doing. Mod 2 wavetable of k plus 511. Mod 2 wavetable is not addressed yet. Where's mod 2 wavetable coming from? Loop, push switch, octave select, mode select, frequency calculations, correct resistance error. So analog read ADC plus that. We're not dealing with the potentiometers right now, but oscillation frequency is equal to the frequency table ADC plus frequency pot. So we're not even worried about that either. 256 times oscillating frequency over 122,070 times 1 plus octave switch. So again, we're not worried about that. We don't need to worry about that. Mode and mod. Mod parameter set. Not worried about that. Not worried about the push switch. Loop 1. We took out loop 1 because it comes from another. So modulation. If mode is equal to 0, mod wavetable of I is equal to wavetable of I times mod. So the mods are what is, so mod parameter set, these are oscillator frequency, these are mod. Analog read, analog read. So this is, the mod is the amount of influence that other external things are having on our wavetable. So as you move the pot, that's going to change what values we're getting in there. And it's making a new wavetable every single time? Dear God. What in the world is happening in this code? In our loop, we are creating a 0 to 256. I guess it's not that much, but it is a lot for it to go through. Mod wavetable I times mod. Huh. So then we have fold. What the heck is going on? There's a lot of weird stuff going on here. This is interesting. We're really getting into it now. So let's see here. What up, Copper? How's it going? So we're getting into what it's doing to these waveforms, and it's creating a couple different big arrays, I suppose, in order to create the PWM levels that should represent these waves. So first thing we're doing is we're going through, and mode is 0, mode is 1, else if mode equals 2, then you just do amplitude modulation. So this would be depending on mode, make mod wavetable. Oh wait, no, first mod wavetable is based on external inputs, influence. And then we do for I is 250, so mod table, wavetable times mod. And then I'm gonna set it all the way up here, maybe. Where are we declaring? I mean, mod doesn't really need to exit this scope. If mode is equal to 0, where are we using mod? Let's look for mod. mod, mod, mod. Maybe we should search. Can I put it in quotes in the search? I don't think I can. Yeah, I can't do that. Mod wavetable is used, and mod is used there. This is where it's using mod. $256 plus mod, but we're still in here. So yeah, so we can keep that in the loop. That doesn't need to exit. So what I'll do is here in the loop, I'm just going to do int mod is equal to 1, so that we don't have any modifiers going on in there. In pouts. So let's clean this up. I hate these curly braces being indented a little bit. I'm very rigid about this. So we created our mod wavetable, and then we create our mod 2 wavetable. So mod 2 wavetable is based on what? Mode is equal to 0, 0 to 256, for int I, else if, else if, else if, else if. And then this one's doing FM, frequency modulation. It only makes a new table when the button is pressed or the modulation is changed. But every time we're going through loop, that's not true. That's not true at all. It's making every single loop of the software, it makes a new wavetable based on your settings, is my understanding. Loop. Octave select, mode select, frequency calculation. If mode is equal to 0, do this. There's no checks to see if anything has changed. Yeah, because moving the pot changes the table every single time. Because that's what that mod is. That's what this is. That's why we're multiplying it by mod. We take this wavetable, we multiply it by the position of the potentiometer or the voltages that are coming in, and then we take that table and we apply the next, like, whatever that fold or et cetera, whatever modifications happen after that. So mod 2 is what happens after it's, has that change applied. It would be, it'd be a little bit more prudent to have it run on an engine of, like, if something changes, then do this, because we're writing this table every single time. But it runs through the table multiple times, I think. Yes, that's the original wavetable here. This one only writes per table set run. But this is created every single loop, and so is this. Every single loop, it's creating an entire table. It doesn't have anything to check to see whether or not the value changed, which would be something to put there. That would be prudent to put there. I could set up should set up a equals for old mod value and old, what is it? What is this multiplied by? Maybe just if wavetable, or if mod changes, then change all this stuff. Because yeah, it looks like it's going through particular ranges of stuff and doing the folds, but it only needs to do it if something changes. So if mod changes, then create a new entire wavetable, which is kind of crazy, but I wonder wonder if you could boil it into equations or something, and just have it run an equation to figure out what the wavetable value is supposed to be. I guess they like their tables. They like influencing the tables and working on the tables and having the tables look up. Because meanwhile, every single loop you have the PWM just looking at a new entry in the table. But like having it actually, I'm going to put that in. I'm going to do a way to detect. So we're going to mod an old mod. It's a float. So we'll do, if the mod changes. Oh yeah, we're declaring it up here, aren't we? Well, we don't need to do that anymore. We'll leave it global because it actually needs to be stored. But, well, actually, where do we get the mod? We would get, I'd run something like get mod, right? So like get mod, or int mod is equal to get mod, and then if mod does not equal, no, if mod equals, no, does not equal old mod, and old mod's global, do this stuff. That way we're not creating a table every single loop. And then inside of the if, we would do mod2 wavetable. Mod table based on knobs and shit. And the mod2 wavetable, what does it even do? It's different for whichever mode you're in. So mod2 wavetable, maybe we do, but wait, the mod2 wavetable depends on both factors. So if mode changes, then our mod wavetable changes. If mod changes, our mod wavetable does not. Well, it does change, but if mode stays the same, and so it would be like get mod, and then it would be, but then one has to run the other. Okay, I'm starting to get a little bit into this. Gear oil is too expensive. I don't think I bought it in a long time. I don't know what the prices are doing. I could probably use some gear oil. So okay, let me review this. What's happening here? We have mode. So depending on our mode, the mod changes. Not the mod itself, does it? If mode is equal to 1, it's in here. What the hell? This one turns it into a case and switch. This one uses it straight up. And then the third one uses it in a weird way as well. Where's mod? Timer plus mod? Huh. $20 a quart for 75 W90? Damn. Is what's happening? Like, is there some? I remember my friends like a couple of years ago had total panic attacks when the castor oil or whatever, the German castor oil, was no longer available. They bought a whole, like, huge stocks of it for their cars. Huge tracts of it. It's so weird. We have all these tables that are set. We have a wavetable that gets set. Then we take that wavetable and we apply, at least in this case, we apply what the knobs are doing to it. In other modes, it does different stuff. So in another mode, we have whatever waveform is selected, and we're making a wavetable using an equation that involves the modifier. We're just playing with numbers here. But then in another one, we're taking that mod and we're adding it to a timer and looking to see when the timer expires. Multiply AM sine wave by AM mod. So let's just choose one of these and just put it in here initially. It seems as though, I mean, it seems kind of wasteful that, like, I guess if something changes, you'll want to do things differently, and I need to kind of figure out how to pack that all in to like a nice little structure, a nice little programming structure. Because I'm trying to get a test done right now. I'm trying to get this thing tested. So if we do like a sine wave, what does that do? AM modulated sine wave and FM 1, 2, 3, etc. All square, etc. But that's for setting the table. What the hell? Let's just say mode is equal to 0, and we're doing, well, wave folding is what's going on here. Looks like adding 1023, 1024. Weird. Let's just take the code. Let's just take this whole big block of code. And we'll just implement it right now. So I'm going to take this stuff and comment it out. If mode does not equal old mode, as things that I should take under advisement later on. The last day was just this stuff. It's just coding. So it's not that crazy. The code is confusing, but what we're trying to do is just get a very basic PWM signal to come out of this thing so that we can see if there's audio on the other side, if all that stuff works out. But I'm also, at the same time, I'm also learning the code. So as I learn the code, I'm saying, well, how do I program this a little bit differently and more efficiently? Because I don't know what, maybe it's the Japanese, maybe it's how they code stuff, but I don't like my microcontroller to be doing redundant busy work as it goes through and does its processes. If nothing changes between loops, I want it to continue to do the thing that it was doing, but without having to perform all of these calculative tasks. It also kind of bugs me that we're making entire wavetables. It's only 256 entries, but we're making entire different wavetables based on like an input that's coming from an external source. I would rather that go into an equation that would then determine what the output is. But I guess it just doesn't work that way in this. I don't like, because the whole purpose of the tables is to free us up from having calculative busy work, whereas if we're doing 256 of the calculation every single time, why don't we just do one of the calculation every single time, right? Why don't we just do it every loop instead of, oh, we're going to build a whole table every single loop of this software. Wild. It's wild stuff, and I kind of want to get it out of the code. It was, it was probably quickly pieced together based on other blocks of functioning code. For int I is equal to 0 to 256, I plus plus, mod wave table of I, blah, 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 blah. We still need the mod, though. We still need mod. So mod wave table is the wave table times mod. This is ridiculous. I really feel like this could be completely restructured. For I is equal to 0 to 256 I plus plus if. Okay. Else. Boop. And then you guys boop, 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 and I booped ya. So every single loop, we're gonna do all this crap, huh? Whatever. I guess I'm gonna go along with it. 0 to 256 I++, and we're gonna put our wavetable times mod, except that int mod is equal to 1. So it's not really gonna do anything. But this is just a test, so. I is equal to 0 to 256 I++, we're gonna fold, and so mod wavetable of I is greater, if the mod wavetable is greater than 511, and the mod wavetable value of I is less than 1023 plus 512. The fuck? Mod 2 wavetable of I is equal to 1024 minus the... Huh? What the heck is going on with that? I don't know what's going on. The modulation we're applying is folded, I guess. I just trust it, I guess. I just leave it alone. We have, it's like conditionals on the numbers, and then it applies some kind of a weird thing depending on the number. So I guess it'll do funky stuff to the wave, but we don't even know that it works yet. So now what happens next? Mode is equal to 1, mode is equal to 2, and then our loop is done. That's void loop. So we got through void loop. I didn't see anything for... These are just to set up mod. Because then well, something weird is going on there. Frequency table, ADC, so oscillator, OSC frequency. Frequency there. On wrap is when OSC frequency is set. And what is that influencing? K is equal to the integer of F, and K is looked up via the mod 2 wavetable. So we need to define OSC freak somehow. Frequency table. Is that set up? Do we have that set up somewhere? Map of analog read 27, 0, 10, 23, 0 to 127. Okay, so frequency table. That's empty, and it's created when we table set, or when we octave select. So that should be populated by the time we get to this point in the code. And so we need to get... Let's see, where is that? 4i is 1024, but what? Wait, but when we octave select, it uses the frequency table. No, that's the entry number. Okay. Hey. Oscillator frequency, ADC plus frequency pot. So... Wait, what are we doing here? Hold on. 1 plus octave switch. So this is scaling it. This is applying it with 0 to 127. ADC and the frequency pot added together. ADC is 0 to 1225. What? So, wait a minute. So it's constrained from 0 to 1225, and then the analog read for the value of frequency pot is 0 to 127. 0 to 1225, that's ADC. Where does ADC come back in? Wait a minute, it's not... hold on a minute, it doesn't come from anywhere. Where's ADC being used? It's... huh? Analog read times calibration, analog read ADC there. Oh, there it is. Oh, geez, I was missing it. ADC plus frequency pot. And frequency pot is being limited to 127, and ADC is 1225. So that little tiny 127 adjustment, there's a little tiny adjustment from the knob, and the external input is like 1225. That's a huge number to be influencing it with. All right, so we need values in here, I guess, for OSC freak. So the ADC read, let's say in the middle, would be 1225 over 2. I can't do math. I can't do math. I don't remember math. Calculator. 1, 2, 2, 5 over, not plus, clear that. 1, 2, 2, 5 over 2. You feel truly stupid when you have to do this. 1837.5. What the fuck? All right, 1837 plus frequency potentiometer in the middle. 127 over 2. 63. 1837 plus 63. 1900. What a weird number to put in there. So oscillation frequency is 1900. And our octave switch is 1 plus. So 256, so 256. Well, actually, clear that. I mean, 1900 megahertz, right? Or kilohertz? 1900 kilohertz? 1900 hertz? 1900, what is a C note? We'll just set it to C note. C note frequency. $261. $440 is oh, that's where's the 440? 436 is A note. Yeah. I don't, so is this going to be our hyper high frequency, our inaudible frequency, or is this going to be our actual audio frequency? I think let's stick with the number that I got. Let's stick with 1900 and just run that through. So 1900 divided by 122070. Is 0.0155. Jesus, is a weird number. Times 256. 3.984. Times 1 plus the octave switch. And the octave switch can give us, in the neutral position, it'll give us the number 1. In the upper position, it gives us the number 3. And in the lower position, it gives us a 0. So it's either 1 plus 0, 1 plus 1, or 1 plus 3. So it would be 1, 4, or 2. I guess we'll do the second octave. So we'll multiply it by 1 plus 1. So times 2. 7.96. What kind of a variable is mod? Mod, I believe, is an int, so we don't get any decimal places. Float. Okay, so 7.96. And that would be the value of OSC freak. So I am simply going to say, hey, guess what? OSC freak is equal to 7.969. That's weird. That's a weird number. 1225 plus 127 means the largest index read in the frequency table is 1352. Okay. Isn't it insane how much mental arithmetic we've been put through, or am I Swedish? I do not know. Running through this code, I'm just trying to figure out what is going on. The folding is a little bit confusing. I think it just, based on the entry, it treats the wavetable differently, and I don't know if we really want it to be doing this, if I'm just trying to see what the output is, but we'll try it. We'll just see what happens. But I have taken some factors out, like oscillation frequency depends on external factors, and since it's constraining those external factors to certain numbers, I've just taken the middle of the constraints. So it's everything is in a neutral position, like Sweden. Oh wait, no, they joined NATO, never mind. Now you guys can't be neutral no more. Wait. Yeah, this is Sweden, right? So we've taken it at kind of a neutral octave. It's whatever. But what else do we have going on here? Analog read, blah, 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 mode. Sorry, mod. That one's like scaled. What in the world? So the different modes are going to be reading the analogs differently and scaling them differently and having them go to different numbers. Yeah, just pop the clutch. There's so many factors in this code. It's so weird how it does stuff. Like, depending on the mode, your inputs are going to influence things differently. Depending on the mode, your wavetables are going to be calculated differently. And it's just so strange the way that they program this. In contrast, the mutable instrument stuff has it more like, here's the inputs, here's the like calculation, stuff like that. I'm trying to break it into something like that instead of having, maybe this was put together very quickly, I don't know. So do we have enough to create an audio frequency now? We set up all our tables and stuff, we table set, we octave select. When we octave select, what are we doing? Frequency table of I times F0 to the power 2, the number of octaves, number of resolution, blah, 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 blah. Yeah, okay. It's weird. Octave select doesn't really do anything with the octave input. But then we have the table being made on table set, and that makes wavetable of I sine 2 times pi times I over 256, and then it multiplies it by 511. I don't know what that's all about. Oh yeah, because it's just the sine wave code. This would eventually become mode dependent. So when it's run, depending on what mode you're in, it'll do all that stuff. So, but for right now, it's just calculating it on startup, and every time the, what do you call it? Every time the interrupt is triggered, it will do that again. Does it? No, I thought it did. Slice number, channel A, wavetable of K, plus 511. No, I guess it doesn't. It uses oscillator frequency, though, which is currently set to 7.96 because we're not worried about other external inputs. And then every loop, apparently, we're going to create this table, this mod 2 wavetable. And then mod 2 wavetable is used in the business of creating the PWM output. I just find it a little strange that we're creating it every loop. Had our gear neutral for 200 years, but NATO was straightforward after the happening. Yeah, fucking ridiculous stuff going on out there. Maybe we should check over our code. There's like weird anomalous like brackets floating around. Oh wait, this is in the other code. Maybe we should check this over, see if it works. Let's run through and see what's going to happen from the beginning, just to give us a little bit of a sense of functionality here. So we're importing hardware pwm.h. We're setting up all of our pins, even though we're only using audio out. We set up a couple settings. We have a PWM wrap, which is essentially the resolution. It's when the ticks of the PWM, which is represented in the Buchow explanation. He's got a nice little diagrams of the stuff going on here. So what happens is, as we count up, our PWM wraps around to the next sequence. And in order to do the duty cycle, it waits particular amounts of time, and then it flips it to the opposite polarity when that happens. So, okay. So we're going through the PWM ticks. We go through 1023, and then we wrap. The CDIV, which is apparently sysclock over the sum of, or the multiple, sum of resolution plus 1 times the frequency. So resolution plus 1 times frequency, the sys clock is divided by, and apparently we get the number 1, no idea why. The number of octaves, we have 6 octaves. The octave resolution, 1230. Any more and it gets unstable. And then the size of the frequency table is 2048. And that's just to get rid of repetitious numbers. So down here we have our variables. We have slice number. K is equal to 1. I don't even know what that's for, like calculating the table. Float frequency is equal to 0. Don't know where that one's used. Oscillator frequency is equal to 0. Actually, do we need F0 in here? I don't think we use F0 because F0 is used when doing the octave, and that's dependent on other stuff, right? Let me just find F0. F0. Oh, no. Nope. That's during octave select, so I actually do need F0. F0 is equal to 35, apparently. Does that ever change? No, it does not ever change. That's why we're assigning it an integer. What was the comment again? It was bass oscillator freak. And so we go all the way down here and we're lowercase f0. Actually, it's still uppercase, so that's perfectly cromulent. That works just fine. That's how you're supposed to do the coding. Calculator's in the way. Yeah, what? Nintendo's not doing anything with it, are they? They still love F0. Oh, those are totally uneven. Okay, let's see here. So F0 is 35. We were going through and initializing. So we got all these variables. We've got our big wave tables that are coming up empty. And then we go into setup, where we set up all of our pins, even though we're only going to be using audio out. We make some huge F-off tables. So we go to table set, just down here. And table set is dependent on the mode switch. However, in this case, and by the way, eventually I'm going to be working with the EEPROM in order to save what mode this thing was in the last time it booted up, so that you can stay in your mode when you power things off and back on. There's going to be quite a bit of code reconfiguring going on here in order to get all these functions. But this is all stuff that I did with other microcontrollers on synthesizers anyway. So we're doing just a sine wave. So for in I is equal to 0 to I is equal to 256, we are going to set the wavetable value of I on this 256 entry table to equal to sine of 2 times pi times I over 256. And then we're going to multiply it by 511. I don't know what the math is doing here. 2 pi I over 256. 256 entries, and we multiply it out in order to make it, I don't know, that much larger? I don't even know. I don't know. Big Gizmo knows, but I don't remember. I'm not good at this. So anyway, we make this entire wavetable, and that's on setup. So now that we have wavetable of I defined with stuff, we go in and we select the octave. So octave select then runs. Octave select says for int I is equal to 0, I to whatever octave resolution, so that value that we have up above, we're going to count up I, and we're going to make this frequency table. And we just made our wave table, but I guess we're not doing anything with the wave table yet. We're making our frequency table, and that's frequency 0, which is equal to 35, times number of octaves times I over the octave resolution squared times the frequency. It's a confusing equation, and I don't know what it's doing. Then, for I is equal to 0 to the frequency size minus the octave resolution, we're going to set it to I plus blah, 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 number of octaves. This is a weird thing that it's doing. I think it's just padding the rest of the table for some reason. Whatever we're doing it initially, and every time octave select runs. And I think that's only once, which is odd. I'm going to have to look at how that's doing. Strange. So we have that now. We have a frequency table that's fully set up. We have a wave table that's fully set up. We do the business of initializing PWM and getting that ready to run, which involves storing the ID that we're going to use to tell PWM to do stuff later. These are like the high power PWM functions. They allow us to do things like set up an interrupt on the PWM driver. These are like tricks to get your PWM to do some really advanced stuff. So that's how we're able to get audio to come out of it. So once we set all that stuff up, now we're in the loop. So once we're in the loop, and we don't have any external inputs, we're just a test program, we're going to go ahead and set mod is equal to 1, which means we don't need mod up here. Every loop we're setting mod is equal to 1. And then the oscillator frequency we're going to overwrite with 7.6969 giggity. From there, we do some kind of a complicated thing with folding the wavetable. So we've already created the wavetable, the initial wavetable, but we're going to populate something called mod wavetable with whatever modified value would exist. That is just a way to put all of your knob inputs on a separate thing. So one thing that I would like to do is build in a system by which it does not update the wavetable if no mods have changed. If the mod hasn't changed, why would you update that wavetable? But then from there, every loop, it's going to go in and it is going to set the modified, the folded wavetable based on whatever 0 to 256 entry is coming in. So it'll modify it and modify it again and modify it again, depending on the parameters that this counting for loop gets to, which is a weird thing to do. I don't know. We just have that on there. So I guess we're folding a sine wave or something like that. And then we loop and we do it again. So it looks like we're doing everything we need to do. And every time PWM wraps, we clear the IRQ, we set our oscillator frequency. For some reason, it's an additive event. If it's over 255, we limit it to 0. K is the integer version of F, which I think is a float. And then we set the PWM output. So let's go ahead and let's check over this program and see how many semicolons I missed. How many semicolons did I miss? This is a mad program. It's crazy. I would like to kind of restructure it. It seems like it should either be doing the calculations on the fly, or I don't even know. Or before float, my floats. Octave, note, and amplitude. That's, I think, that is the chord VCO. There's only 2 knobs on this, but the 2 knobs also have, one of the inputs is volt per octave, and another of the inputs is the control voltage input. And so those influence the knobs in particular ways. And the knobs also, you know, do their job of adjusting stuff. Freak size. No, my freak. It's SZ. Where else did I use that? Nowhere else. Freak size. Freak table. Freaktable. Freak SZ. Why didn't I catch that earlier then? Freddy Freaker, party time. Don't know what's happening now. Call now. 1-800-5 freak. Okay, let's see. check it over again. What mistakes hath I made? What have I done? Oh, I ran out of liquid is what I did. I don't think I have anything to drink. Eesh. Yes, yes, yes. Is that going to compile? I think it is. We tried to keep it as simple as possible, but damn, this thing is crazy. Yeah, Freaky Friday. Freaky, freaky. You're 30 seconds behind. Holy crap. Damn. That is a big delay. All right, so let's plug in the 2040 and let us code it with our code. I went through all the trouble to set this thing up so that we could punch this thing with code constantly. And I'm only just barely getting one program to run on it. But at least it'll be progress. The opposite of Congress. All right, so plug in the RP2040 with this nice USB plug. Go over to the software. And I'm more comfortable just choosing a port. So port COM4, and it's xiao RP2040. I don't care. Okay, we're ready to go. So upload. I guess there's no TXRX light on the thing, huh? Should happen pretty quickly. I don't know if it's, I think it's a USB 2 cable anyway, but wrote 1 billion bytes to F new UF2. Now what? Now what do I do? I think I hit reset. Pop. So theoretically, if I were to connect this scope probe and pull up the scope. Scope. No, that's not it. Scope. Boop. And I connect this to ground, which is this middle pin here. And then I probe, which one was it? Oh, I gotta pull up the pin out. It was P2, right? P2, which is 2 from the bottom. Whoa! Whoa! It's like a super duper crazy. Where's that trigger at? Hello? Edge, blah, blah, blah. 1.24 volts, rising edge. Handoff, 800 nanoseconds vertical. Channel 1. Yeah, so that should be fine. So why is you not stabilizing? Holy shit. That's why you is not stabilizing. Wow. That is a freaky wavetable coming in here. And it's being calculated constantly. This Raspberry Pi is wondering why it keeps having to calculate the exact same numbers over and over again. So now we get to see what happens to that when it goes through the Schmidt trigger. So let's go ahead and power down the RP. Oh, okay, bye. There we go. Just decided to leave. So now what we're going to do is I'm going to take our power and ground and I'm going to hook them up to the RP2040. So I'm going to go ahead and do that one there. Got to make sure I get it right. This thing is currently powered. This one's power, so that goes right below it. There's that. And then this one up from the bottom. And theoretically, all that's said and done, we should see audio, but we don't. I'm not seeing audio out of this thing. Of course, none of our controls will do anything. We're pretty much fixed. This is not plugged in currently, and it's just plugged into the audio output. Audio output goes through all this stuff, but it should still have all of its references and things. What if we AC couple channel 3? So coupling AC. Still nothing. All right, so this is our first problem. Could it be a software problem? Maybe. Channel 3 should be showing all of the audio levels running around, because that's this cable to here. You guys can't see that. That's this cable to here is channel 3. So we do know that there is PWM output on that channel. It's just we're looking at it through our filters. And if we look at it in terms of DC, then we just get a solid voltage level. If I zoom way out, center time. Turn this down, maybe. It is at 10 volts, though. That's not a good voltage. Well, no, I guess that is... Well, no, that's not a good voltage for our output. All right, Schmidt, I think your trigger is busted. That or the frequencies we're outputting is not appropriate for this thing to create the audio that it needs to. What happens if we lose... Oh, we're just solidly outputting 10 volts, huh? That doesn't seem like the right thing to do. And if I check here, we're outputting PWM properly on the right channel. Yes, sir, we are. Woo, look at that go. Look at that go. So, what are happening? We should be outputting something like 5 volts. We shouldn't be that high voltage. Weird that there would be this type of hardware issue here. Whoa, we're outputting 1/3 of an amp? Is anybody heating up? We're using up 1/3 of an amp. I guess the microcontroller is a little bit hungry. Hungry microcontroller. So yeah, it could be a variety of factors that are influencing this thing right now. Mainly that I don't know what I'm doing with my equations and stuff. Maybe we chose a bad octave or something, or somewhere that it's not supposed to function. It's also possible that our Sallen key filter has is tuned wrong to the wrong frequencies. Although I think we would be seeing something like an audio wave, even if the Sallen key filter had its values off by quite a bit. I mean, this right there is approaching some kind of a signal. It's not quite there, but the yellow trace wire, by the way, that thing is limited to, the scale is on the scale of 3 volts. So we're not outputting 10 volts. We are outputting 10 volts on our audio channel, which, you know, it's what it's. Like, I think this is the desired effect. If I pull in like a low-pass filter and build it on the breadboard, I wonder if that would look similar to Hagiwo's experience. What do we need for that? We can build this filter pretty quickly because it's a very simple design. It's simple. Zoom, 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 zoom. 1Ks and 10 NFs. That should be easy enough. Actually, the problem with that is finding 10 NFs. Oh, I got them right here. Okay, cool. 1Ks are over there with the resistors. Let's grab those. We can just very quickly build a low-pass filter out of resistors and capacitors. Let's do it. Whoa, I almost fell over. Jeez, stool's in a weird spot. 2 of these. And then 2 of these. good to have a set of these. These are good to have around. Nice high quality caps. Actually, I have no idea if these are high quality, to be honest. I think they're just accurate. And I used up all of the 47 nanofarad ones on the Bic and Tick filter, and that thing doesn't work. Who knows? Yeah, the timing of the frequency here is so high that putting LEDs on there is not really going to net us any positive results. All right, so I need ground. Take ground and give it over here. And then I need my input signal. Take that. And I'll park it here for now. And then we have two 1K resistors that are in the path of the output signal. I'm not going to bother to cut the leads on this. I just want to build the filter. So let me see here. Got that going here, and then another one coming out of that. And then both of these get a capacitor to ground. So this one gets a cap to ground. So input resistor cap to ground, and then that goes to a resistor, and then another cap to ground, and then output. So this is the other one that goes to ground, and so I'll put that just on the other side, like this. It's a little confusing, but it should be just fine. And that is our output over here. So now we can observe over here on our yellow trace, and I take our input signal and I apply it to the low-pass filter. Ah, God damn it. So we need to work on my circuit. My circuit is not good. That sucks. Mainly, I am lamenting that this works perfectly well from Hagiwo's circuit. We have a perfect... What is even the frequency here? No, remove that. Frequency. Source, channel 1. Vertical. No, wrong one. Measure. Horizontal. Freak. Channel 1. Well, it's going to have a little trouble measuring it. Yeah, so we need to, I guess we need to work on the values of the Sallen-Key filter and figure out how to get that to function in this circuit. But we have a low-pass filter, and so we can run it through there and figure it out. We can turn that low pass into a Sallen-Key. I know, it's a paradoxical response, but it's the original circuit works. My circuit does not. That's sort of my annoyance right now. So I think I can get the same results from the Sallen-Key filter. I'm gonna have to run some numbers. I'll have to do a couple equations there, but you guys can see exactly how obnoxious this kind of work is. But once we learn all the principles of it, it'll be a nice little circuit that I can work with. I just need to make sure that my circuit works. Test my circuit. I already did. That's what we've been doing. Actually, we are constantly testing my circuit. You can see that's the output, the pink 10 volt output. Positive 10 volts is coming out of my audio output, which is strange. It could mean maybe that there's like a bad solder joint or something like that. I don't know. But apparently just Hagiwo's method of doing 2 resistors and 2 caps is perfect. Like, we got a sine wave output on that. So we'll have to work on that. What Hagiwo does after that is he puts it into an amplifier, and then it hits another capacitor, so it'll set it back down. Putting it through another cap will basically destroy the AC, and it'll be centered around the 0 point. Darn. He actually, it's a 6.8K on that too. So he takes this and he actually 0 to 6.8K. What kind of a, is that inverting? Weird. Anyway, okay, so I know where I want to go. I just need to recalculate the values of the Salon key filter. I need to get into that and figure out exactly what's going on there, because the RC filter works perfectly well. I hope I could do the same thing with this guy over here. Not that guy. Which guy? This guy right here. Yeah, I don't have the pinup up in front of me. I guess I can look at what it's doing and whether or not it's actually functioning. Because given like 10 volts on the output seems a little bit odd to me. I just don't know where exactly that filter is resting on my circuit. Let's see if I can find it. So it's going to be the TL074 down here, and one of these pins, oh, look at that. Well, that's looking a little familiar. Something else has gone wrong with it. Huh. All right, I'm glad you pushed me on this one. Because we do have a wave here on the output. Just for some reason it turns into 10 volts. Don't tell me it's like outputting somewhere that's not connected. There's a little buddy. It should be right here. Or no. Why is it on the upper one? The upper one should be, I guess the upper one is the output. So it should be up here. Yes, yes, yes. You have different properties of it here. There it comes in as a PWM. And if we go over to the other side here, let's get real close in so you guys can see what I'm probing. So over here, it's coming in, and it's coming in from, well, it's coming in from the microcontroller, which is all the way up there. So it comes all the way down here. It's not on this now. All the way down here and over and into this little Jiminy John right here. Not quite. That's where it's already been sinusoided. So let's do that resistor. Actually, by the time it gets by that resistor, it's become a wave again. So I think what's happening is this is not getting to the second op amp. Because down here we should be seeing that wave coming in. Yeah, and I'm just not seeing it anywhere. Why would it go to -10? That seems pretty crazy. What is that signal? Oops, that's channel 1. Oh, that almost looks like it. So maybe it is getting to channel 2. I need to have the circuit board in front of me so I know what's connected where. Hold on, let me take a look at this. That's where CV is coming in. From what I thought there were 2 op amps in the audio out schema, and one of them's the MCP and the other one's the TLO. So the MCP should also have some of this crazy town going on. It doesn't. No, because the MCP is for the two inputs, right? And the TLO should be entirely for the output. Did I screw something up with the circuit? Hold on, I may have to look at... No, because the TLO7-2, the only use for it is for the output. Right, okay. So that's anything here, the lower half of these, and this stuff down here. So on circuit 1, the output of the op amp, we actually have stuff feeding back and outputting just fine. So from there, where does it go? Power. Oh, right, it goes out to the capacitor. Maybe the capacitor isn't soldered down. Poke it a little bit. Let's check the two ends of the cap. So one side, here, you guys come over here. So one side of the cap. Just almost nothing. Other side of the cap. It doesn't even get to the cap. The cap's at negative 10 volts. What the fuck? What the heck? Okay, so the capacitor comes from down here. Goes down to here, and here, here, and here. That one was a little weird. Well, it's still very negative. Where are we even getting negative 10 volts from? Here, 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 and here's ground, I think. Oh, that's growing. I'm growing. Negative, strong negative. Everything on this side is fluttering away, right? It's chooching away. It's doing its thing. It's creating all these wonderful little wavies. Oh, wait, did it stop? Did I slip? Did a thing slip? Did something happen? What's going on? Where's my waveform? There's no waveform anymore. Wait a minute. What about out here? Nothing. Nothing. Where PWM stopped. The Raspberry Pi stopped. Whoa, why are we drawing an amp? Whoa. Okay, that's my, you guys would have seen it if the thermals were pointed in the right direction, but my power cables are all smashed on top of one another, and so we had a short out. That happens occasionally if I'm not careful. Put that there. There we go. Okay, so now everybody should be doing their thing again. Yeah, there we go. Oh, purple's getting some weird results now. So, probing around downtown. Poking things is good. What's up, Short Lurker? How's it going? Well, it seems kind of pithy now. It doesn't seem like it's kind of a good... That's getting close to a good waveform. And that becomes this, like, bump, but it only does it when I contact the board. What's going on there? There's that. That signal again. So where are we inputting to this one? It's on the other side of a resistor. It should probably be like somewhere around here, huh? Not quite. It's a little bit baffling. Little bit baffling. We get the good sort of pseudo sine wave. What I do find interesting as well is that we get a perfect 0 to 5 volt sine wave out of this, which is pretty on point. So I think our Sallen key values are pretty good, It might just be that as we move into higher frequencies, we don't get as much stuff out of it. But there's our signal. Where does it jump over to the other one? It goes over to that cap over here. Poking the cap doesn't really do anything. And then looking at one side versus the other of this big capacitor. Well, hello, look at you. It doesn't look like cap did anything there, though. Is the cap backwards? It strikes me that the cap might actually be backwards. No, that's the way that it was in the schematic. It should kill the DC component, and I put exactly what was in there. Does it need to be a ceramic cap? For some reason that goes full negative on that after the cap. There it is coming in, and it turns into this little bastard. That's where it comes in. Oh, no, right there. It's coming in at negative 10 volts too. That's a little weird. Yeah, that's what that's principally it should be doing that. Because yeah, it's a 10 microfarad, and that's what I have in there. I have a 10 microfarad 50 volt cap. Positive is facing towards the good stuff. The band is on the negative on these things, right? So that's what positive is seeing. The positive, oh, you can't see it. You can't see it on this view. Haha. Well, anyway, you saw it before. It was that just nonchalant sine wave looking MF. But then on the other side of the cap, it's like negative 10. So it's something happening here that's not good. Well, it's pretty well installed. Can't really complain there. And then from there, we go. Actually, I don't know where that one comes in. That's one side of it. I guess it's coming from there and going this way. Could it be a resistor's not quite soldered in? Maybe the capacitor's not quite soldered in. These all look pretty well attached to the circuit board. And as I probe them, I do get varying values. Varying voltage values. Did Stan Lee write this? Hold on, I'm stuck. My power cable is stuck. Okay, let's see. That's on kind of an angle, but... And then let's see, do we scope in here? Man, it's nice to have the scope on screen. So up here, we're coming in with this signal, right? So down here, in this area, it's on an angle, so it's hard for me to get focus on everything at once. Output is somewhere around here, right? And so that output comes out and goes around and comes back in here after the capacitor. You can find the via for it. Where's that via? There it is. That's after the cap. And then before the cap is probably right next to it, yeah. Nope. Where do you go? Where are you going? This one, and the cap's over here. So I was like, that one? Actually, I think it's this one. No? Okay. See, right there. Then you get it in varying flavors back here. But anyway, the point is It goes up and it hits that capacitor, and then it comes back in negative. Strongly negative. I don't understand that. How would that work? How is that even possible? We've broken physics. And then it comes in here, and we have positive and negative 12 volts. What? You just jump it in with like a homework question? Is that one of your homework questions? Is this little freaky guy right here what's doing it? No. You know, it almost feels like this would work just fine if for some reason the signal didn't turn completely on its head. But I don't see any like possible shorts in this area. I don't understand what could be doing this. Our output is this weird little signal here. And it's possible, well, no, because that's not the Salon key filter. This is just an amplifier on this side. This is just an amplifier. It's just designed to clean up things a little bit more. We have a strong negative signal coming in here. And yet somehow, I don't get it. I don't understand. We're so close, though. It's so weird. Seems to be somewhere around C13, things go a little topsy-turvy. So C13 is, I think it's the feedback capacitor, which might mean that the frequency is so high that C13 is damping it out. That might be what's going on. What frequency is this? I don't even know. I would like to see oh, there we go. 4 kilohertz. That might be a little high frequency for us. What does 4 kilohertz sound like? So I think everything's functioning exactly as it should. Ah! That's 4 kilohertz. Maybe we should turn it down a little bit. Let's change the octave. So before our frequency is 7, so we're going to turn it down to like 3. .25. And let's load that code into the Raspberry Pi. Into the Raspberry Pi. The Raspberry Pi. I don't think any of the audio stuff is designed to make exactly that frequency. Yeah, we'll take it down to 2 kilohertz. I should probably take it down a little further from that, but we'll just try this out first. I decimated the number. I halved it. So now, unplug and plug these things back in. Probably could program it in circuit, but I just don't want anything bad to happen. And then ground. Well, can't say that that's outputting anything. But we can check where the circuits are. Okay. So it's a lower frequency for sure. But it's going into the filter, and it might be getting filtered out. It's still very strongly at negative 10 volts, though. That's not right. Something else is going on here that I don't like. Maybe we can get a frequency off of it. Hold on, let's try it from the other end. It does look very clean when it gets there. Yeah, almost 2 kilohertz. Two kilohertz is that way out of spec? Should I go way lower than that? Two kilohertz is not, I mean, that's a like sensor noise-ish, or like censoring, like a beep. Actually, it's double that. Ugh. Okay, so let's go like 1.25. I'll try plugging it in circuit and see what happens. Nothing bad. Problem is the offset of the final op amp. But it's going into the capacitor positive, and it's coming out of the capacitor negative, and it should be centered on the number line. Got a little bit more going on the scope. Got loops. We have loops, or loopies. That didn't really, well, 600 hertz, that's in sort of the nice audio tones, right? That is a good audio tone that we're getting. So now it's down to other stuff doing things to our signals, like turning it strongly negative, for one. Yeah. I don't know, it's possible maybe a component's not quite soldered in correctly. Something's not quite making good contact. These numbers are weird. These are weird numbers. I really need channel 2 in here. These numbers are weird. So this is occurring, the red line is, or whatever, magenta, what is that? Is red. The red line is occurring at the audio output, and the yellow line is occurring right before the capacitor. 0 to 5 volts, perfect little signal at the end of the Sallen-Key filter, and it's nice and smooth. It looks very, very good. That's happening here. And then the other one is happening here. So something's amiss in here. Bad value component, bad capacitor, bad solder joint, something of that nature. I am going to have to look at this and see if I can get rid of that. But it turns out our code works for some degree of what it's supposed to be doing. There's some problems with the code that I need to vet out, and part of that, a big part of that, is going to be looking at how I can make it to not generate that table every single loop. We don't need to generate a 256 value table every single loop if we're not using it. It's possible that it would get through most of that loop, but the scheme with the interrupts and the PWM and stuff like that, that's all happening properly. It's actually doing pretty good. I guess I just need to look at either the values of that final amplifier or what's happening to my signal. It seems almost like a negative 10 volt is being, or like a negative voltage is being applied to it or something, or it's being inverted somehow, but I don't understand how that would work. I mean, the line, these polar capacitors, technically that should block the AC and, well, no, it should block the DC and shift everything back down instead of shifting it way down to the negative. So I don't know what's going on there. Some weird stuff. Strange things are afoot at the Circle K. I mean, like here, SMD capacitor markings. I wonder, I might have some tantalum capacitors that I could possibly try in that role and see if they're, what the heck? Why is the thermal camera up there? Weird. Images, dragons. So the negative is facing towards the rest of the circuit. That's how I have it. That's how I have it. and we were looking at it at the 24.9, and it was strongly negative. So we were actually getting that instead of where we theorized it should be, which is that. Odd. So I'm gonna have to take another look at this thing and figure out what's going on. I'm out of steam though. It's closing time here. We've had a pretty good Friday. We got very distracted by modular synth heads, which is typically, you know, normal of the way it happens, because you know, I put modular synthesizer in the title, and so they flock in and they come in and they've got all this weird knowledge that we know nothing about, and so it's kind of really cool to like pick the brains of people who have measure it pin 3 on the amp. All right, yeah, I can do that real quick. Turn this back on. 1, 2, 3, right there. Pin 3, we've got a positive 5 volt kind of jittery nonsense signal. Oh yeah, 1, 2, 3 is over here. We've got a positive 10 volt kind of jittery, 5 to 10 jittery kind of, that's just the trigger setup. I can do that, and I'll smooth it out. Yeah, that's a pretty heavily positive. Sweetenite keeps the Danes away. Don't you just have to leave alcohol outside and they'll just kind of scarper off? This should be grounded. And 3? Hold on. That would make sense. 3 to ground. What do we, I guess I'm just gonna have to open Fusion 360 and see what I did. Let's see what I did. Pin 3. Did I swap the pins? That might have happened. That might have happened. I might have swapped the pins. In which case I'll have to do a little robot surgery, but then I'll also have to, I might have to order new boards if that's the case. That's why we do these checks. Ah, man, I don't want to spend that money again, but I will if I have to. We'll do sort of an in situ repair of this if that's the case. So, come on, RP 2040 VCO. Oof, this thing is taking its time. Oh, it's probably trying to download an update. Bodge time, yeah. It's in the right way round. Give me some credit here. Jeez. I don't care about early access to a new feature. I'd like to use my CAD program now, please. Please. Come on. I should have started this up a little while ago. Wow, my chat up there hasn't even updated. The social stream blade updated. It's just, I guess opening this up kind of slowed things down. Well, that should be grounded. It's literally connected to ground. What the fuck? Is there like a bleed from the silk screen? That is correct. Double check with the schematic. Ah, it is flipped. Okay, that's flipped. Yep. So we can correct it right now, but I've already got 10 boards. I think maybe I gotta toss them in the garbage and just buck up and order them again because I didn't notice they were flipped. So let's take these two pins and do a pin swap. How do we do that? Gate swap, swap library value. I thought there was a pin swap, not just a gate swap. Stop telling me what to do. Stop it. Stop. All right, let's see here. I can grab this. I can flip it vertically. That would be one way to do this. It's no, you always do this. You got to stop doing that. Breakout pins could potentially do it too, but I think what I want to do is just flip it vertically, and that's one of the controls that I have. I forget which one it is. I guess I could flip it like that and then do the center click to flip it like that. There we go. So now that's like that, and I can just place these. And then we go to this, and I'm gonna have to do this with both of them. And we move you over here for now, and we can just take this, bring it over there, and do a nice little line like that. Oh, but not that size. And that would be what did I use? 0.3. 0.3, not 0.48. There. Okay, anything else that needs done? That's a little close, but I think it's okay. Let's see. So we already did I do the C and the R marking here? Oh, I need to flip the board. Floop. That's why it was confusing. I was like, oh yeah, pin 3 definitely is. No. This is what it actually looks like. So yeah, these two were swapped. But I had the board flipped because we were viewing it from the other direction. Disc 1 of 5. Hey, it's been a little while. What's up, Rick? Something? We found a glaring, awful error in my design, which is why we're doing what we're doing. Basically, the way that this program is going to work is it's going to influence the PWM output of the microcontroller and put it through a what is it called, Salin key filter, and that will kind of smooth it out and turn it into an actual audio wave. So you output a really high frequency PWM and you chop it up. You change the not the phase, but I guess you change the duty cycle, and the amount of energy changes. And so as you put it through that Salin key filter, it'll become an actual wave. We were getting some really weird results on the output, and it turns out, well, we tested pin 3 to see whether or not ground was there, and I was like, ground doesn't seem to be there. So I opened this up in the design, and because the board isn't flipped, we're looking through the board. And so I was like, yeah, pin 3 right here is definitely ground. No, this is actually what we're looking at. And so this pin over here, or no, well, it was the other way around, whatever, it doesn't matter. But yeah, the pin that was supposed to be ground was not ground, and so we have now fixed it. Did I fix the labels up here? I did not. Yes, I did. Yeah, that's fixed. So, I mean, for the most part, I think this design is now working now that we've swapped those pins. I can pull up the pins on this one and reconnect them and get that functioning. So we can continue with these until I feel like ordering new boards. Before I forget, I'm going to open up the second one, which would be actual chord VCO, and I will make that correction there as well. I'm doing okay. I kind of need to tighten up the bolts and get my health under control for whenever my next doctor's appointment is, so he doesn't have a doctor's disappointment. This one should also have a Salin key filter for the actual chord VCO, and I need to make sure pin 3 is in fact going to ground on the amplifier. Oh, no, that's the wrong one. Down here. Damn it! Made the mistake twice. And go over to the design, and then make the correction. Or is it right there? Oh, that's a nice easy one. Well, that one's a little more tough. That one's a little bit more challenging. Park you over there. This comes down here. This is a 0.3 width. There. But then, how do I do this? Well, I guess I'm just going to have to make this whole area kind of weird. That's ugly as hell. Okay, hold on. What's going on over here? Wait a minute. What's going on? Why is my computer hates me right now? Hold on. Bengismo! Hey, thank you for all the gift subs. How many was that? 1, 2, 3, 4, 5. Hey, thank you for the gift subs, man. 5 tier 1 subs. Hell yeah, look at all these people. Hey, I appreciate that. Yeah, we had RYG for 22 total months, Miguel Oz for 48 months, Makotronics for 66, Jojo Yolo for 9, and then Big Gizmo gift subs to Trade Splatter, Veronica Cure, Sleepy Shaman, The Real T-Bone 29, and Yarkis 42. Thank you, Big Gizmo. Why is this? Hold on, my stream thing is like the for some reason the social stream thing that was running chat on that scene like just derped out and didn't work. Yeah, it's still not working. Okay, hold on. Where's social stream blade? How do I manually refresh this? Refresh browser when scene becomes active. Well, that may make it blank out every single time. Well, oh well. Oh well, lost a ton of comments there. It's fine. Okay, so what am I doing with this? I'm trying to make it look all right. There's nothing about that I like. I mean, it gets the job done, but at what cost? At what cost? Fine, I guess I'll just leave it. Beggars can't be choosers. All right, save that one. Now it'll all work, theoretically. Although we do have to see what kind of errors are in this one as well. But I've flipped the power cables on both of them, and I've done all of those other little revisions that we've needed to do in discovering stuff wasn't working quite right. Although there haven't been many errors, there are a couple. I don't think it really shouldn't garner ordering an entire another board. I don't really know how I'm going to be able to do that repair, though. And if I need to do it on every single one of these VCOs, or if time is money and my $50 for both, sets of 10, I think maybe I do just need to spend the money and get the repair, get the repaired boards, and then I can build those and throw the Raspberry Pi 2040 on it, and we'll have like an amazing audio signal coming out of the other end of it. And in the meantime, I can figure out the coding and what needs to be done there. As far as I'm concerned, every other system on this thing is completely it's good. The switches work sort of. I mean, we haven't tested them, but they're switches. It's a direct control. The LED is fine. It's just on a pin, right? The voltage regulator isn't overheating. The op amps, we know, carry the right calculations in, so if we give it negative 10 volts into one of the inputs, it will just simply go down to 0 volts on our microcontroller. So that's perfectly fine. If I go to negative 10, it'll go to, I think, the 3.3 volts, and it won't go any higher than, it'll go to 3.2 volts, and it'll just stick there. So I think hardware-wise, we're good. Software-wise, heads exploding. Double hardware-wise, in terms of the circuit board, I think I need to order more circuit boards and maybe toss the old ones and just never talk about them again and pretend that they all work all the time. I may do that. I may do that because that's a pretty glaring error, and I don't see, especially considering how tight that area is, I don't really see myself being able to fix it easily. Because what I would need to do is cut the negative from the one side of this and this side and solder that back in. And on the other one, what would I need to do? What would I need to do in order to repair this? Yeah, I need to cut on both sides of the chip in order to sever the one pin. Getting stuff to ground is easy, but then I would need to cut the input line and then maybe just scrape it and do a little bodge there. So I'm going to remember it and remind you. How dare you? Oh, no. No, it refreshes and then it kills all the comments. All right, so I'm going to make that not refresh. Don't refresh that. When I click don't refresh, it kills the comments too. Oh, well, looks like you guys are censored. Nobody will ever know. All right, so I'm done. My brain's mush. We got partial success. Mostly everything works. It's just I didn't check my pluses and minuses for a flipped component, and I really should have done that due diligence. So that's on me. I guess that's going to cost me $60, unfortunately. That's about how much it costs to order all of those boards. So I'm going to do that order in the near-ish future, and they'll get here in about a week. So in the meantime, we can work on burn the subs a little bit and kind of get our ducks in a row in terms of that software, because I'm interested in really reorganizing that software to function correctly and, you know, use equations more and be just a little bit more readable. Anyway, thank you guys for joining me on this Friday. There's been about like 50 to 60 people here, and every single one of you, you get a thumbs up. Thank you. I will catch you guys on Tuesday, and we'll see what we're working on. I don't know what exactly we'll be doing, but I'll be here. So if you're around, check it out. I gotta do the end card. Wait a minute. I gotta do the end card. I gotta do this one. That's where you can find me. In a club, bottle full of dub, all that stuff. And I will catch you guys on Tuesday next, all right? See you later.